It should be starting at 9.
Okay, no problem. If you need something for you, I will explain and go through and I will probably do that here. This is it. That's what it's not for. If you put the dog in your house.
Don't worry, I was alright. And I even feel the ball for you.
Thank you, my people. No, I say I will do this and I will probably do it.
No, people are.
I can't hear you. Remember, I said to you, I'm going to come. I'm just going to give my copy and I think my
Okay.
bukan. Terus saya semua jalan itu kampung. Juga Even though we have a silver company.
But you are working for that company, you are or you working with WCEB?
No, for that company, clean company.
So that, yeah, you must look at your contract with him.
Yeah, that's the akan itong dito. Ano kaya ako hindi kami dito.
So isn't maybe the leave is during the okay, maybe that is actually something drastic.
Kasi may isa pa mag-start na. Para talaga bitin. Mana market mo sa mga. Sabi ko, kung magpasan ka, oo. Tigas, ang naman, hindi mo di pagkawa sa kawan ng panstart natin. Netitik yung tuloy na mayaan sa pagkara. Iti, siya mo si pagkawa. Siya rin may hatang sa pagkawa. Kaya makikitin ka pa sa kaya. Siya rin mag-drive, ang pagkawa. Di man ay kapasahan ng pagkawa, plus ikaw mami, kung ano ko pagtinda, Ikit-ikitin tayo kung pagkakas na. Kaya hindi natin maaari kung may tawas na bitaw, kaya mo kapiyaw. Kasi niya, iso ka pala. Kaya ano ka timanda. Kasi ka bilang ko, may isip na tayo siya iba, ito suki. Tingbiga. Tigay mo yung erase. Tinta sa ito siya ba, ay ito kaya ako nagbiya ba yung erase. Hindi kasi soon. Sige sa pagkain natin. So kaya doktor, yun ang doktor. Kasi di masuk pa ano tayo. Alay siya tayo. So, siya sa tapos tayo, siya. O kalau kasi siya ako, may tayo ito ba sa salo. Ayaw, yung kamustahan niya, gusto ko ito. Mengenal dia pada sebenarnya pada sebenarnya seperti kita sudah saya mamai kan kalau macam itu pun saya mau kasih itu pun mai bisa punya antara itu pun dapat cari kan saya satu guys kemudian ini ada istri mau ya itu
Yes, I think that's why we have, I think it's because of all the other days to meet. That's why they're already
memang tahu, kalau ini betul, ni kita mesti jawab ada dua dan betul nanti kita sudah ini agak lebih after kita kita macam kita apa sesuatu kalau, tu Saya menyesal. Jadi bahwa banyak ni kau lupa. Tu kan mesti ada hospital tu. Tiada orang. Silakan dia tu. Jadi kalau macam mana ada. Esok kalau kita macam ekala bisa saya hospital tu kan mesti. Kalau macam hospital tu. Silakan dia macam itu biasa lagi. Silakan macam tak tu. Entonces, era que quería meter en el hospital, entonces comprando para ir de extra. A tu casa aquí, para estar con tu ministra, parte tu. Tú se iba a ver. ¿Qué me enferma el estómago?
What were the things?
Al andar a traer. Entonces, mira, que me enferma el estómago. Ayer me día, que alguien te agarra, porque tú se mira, que lockdown. Dan kita bisa kita lakukan itu, ya, lagi ada perang ini dia ada itu stani kemana, terus ini saya itu stani kemana, terus ayo, itu kalau ini saya bukan, atau kalau seorang susi ada itu sudah, anak salah, seorang susi ada asal dia sudah, terus kalau saya mana, kalau mana punya. Bisa. Terus maaf pun, kalau makan seperti Orang lagi 30 hari. Kalau ini itu mah pasti yang lebih itu. Bisa aku rasanya dia tidak akan kira-kira kalau kita tahu. Kalau kita mau tahu.
Yeah.
So
Do it that way. And but meanwhile, if I were using, recently I translate people on this kind of news means try and see if you can, if there is a post, right?
the CV also.
Yeah, put the CV into WCD and see if they've got spaces like only limit. See if they can companies people. Because it's hard working like that for a company.
My friend, saya kerja masa itu kalau ada posisi saya bisa. Saya ini kalau semua, kalau semua.
But then now I know it's an option. Yes, you can. Yes. Tadi tu minum sugar, masa minum sugar. Sugar. I know they're not saying they turn on each other. Just Lucia, do you want breakfast? Lucia, do you want breakfast? I'm so tired. Okay, I will keep this on. Okay, that's fine. I'll be ready. In fact, I'll be standing here. Okay, I'm listening. Okay. Huh? No? No, I'm going to late. I'm going to make sure that everyone's stuck with me.
He did not follow out. No, this is what I do. Anyway, the everyone out. And the other is followed out. The other is told me was a soon, was so, over the soon. The other no, I said, oh, how the other no position from as a supervisor. So she can make a hand back. And so when someone else could have taken the supervisor, man, no, they got no, I got. Process ng mga who's FPO. So, kalau kasi visit ka na dahil na ako, supervisor, as I, kahit yun na matapuwa ko.
But people change.
Yeah.
And I think there's something that we need to understand. We need to. But it can also be that if you class life, you realize that you must think everybody the same. Because I have a position doesn't make me better than you. Or you say, I treat you the same. I'm not going to treat you differently than you. See, it goes with your experience there. If you see other countries, you see white people cleaning. You see white people cleaning because it's not about color coding clean. So it's not your color that makes the person. People are equal in the sense of they've got a job. If you've got a job or you do something with your life, where you live mustn't define you. And what you do must not define you. Unfortunately, we all sometimes have to take a position or we have to do different things. But to treat people, sometimes you must Sometimes they say we're chatting now.
Mm.
So I'm sitting from my work, but you know that's not right. When you're talking, the street person as a human being, right is right, you understand?
It is not how they know. No, I don't respect nanti aku ke akan lupa apa dia. Ini dia itu kalau spesifikasi sendiri. Kalau memang itu terlalu. Tapi serius aku nanti mereka aku. Kayaknya standar sudah. Kalau kita nanti sudah nanti mereka. Saya sudah apa lagi dari itu. Terus saya mau tidak Quando cosa uma nova fantasia presenzione ada yang sekolah itu ada itu jalan que usa opções de todas em volta em área quando já tem opções então que tem você já vai encontrar isso não cada coisa tem não tem tem onde ada jadi tinggi Kalau aku Indonesia sesuatu, aja bahasa di saya Indonesia kok bahasa kalau pun muncul tunjuk nanti, asyik cekai, asyik aku ke bahasa dia, apa, bahasa hati kekse, apa lagi saya itu, yo, sesuatu, istilah kan ya terdah sesuatu so. Deep ini ada yang kecil orangnya jika aku waktu kalau dia akhirnya mesti dan punya itu ini kalau ada yang ini kalau orang apa sih dengan kita harus dengan kita harus
di apa yang memberikan you should still learn
apa sekali itu yang tidak bisa. Pada dia aku pernah itu kan itu nanti itu waktu dia itu sendiri proses itu hasil untuk itu tapi ini aku seperti kalau
yes, saya tahu what must do.
Ini kalau saya ini mana kan benar-benar
Ada kan dia tahu sih people pasaran itu sama.
Ada apa jangan kita lagi ya hasil saya pakai mana itu
But that's why I can't do. You see, once we show ourselves, and it's not even again.
itu kalau ini itu sudah banyak
It's really beautiful. They must just go for something else.
itu kan kita mau itu terus orang yang berkata ya masih itu kan mana kalau itu tapi itu pasti kita ini karena ada sesuatu itu ini kalau sesuatu orang tapi dia kan punya itu tentu wajar orang itu juga itu itu kita bisa melihat sesuatu itu kenapa sih itu harus ini macam itu kayak saya seperti ini harus kalau Islam itu apa namanya kita dia itu kita lakukan ini ambil yang mana itu kita bisa akan tahu mà cái tâm khi tôi chúng ta tôi nói chúng ta là chúng ta ngày xưa thắng cái quả mà chúng ta đi nhỏ nó sao nó thế cái tâm cái cũng mang tốt thì chúng ta suy vô là tự nhiên tại cái bây giờ thắng tôi nó vui ra cái nước thì kita wanita itu masa kemana ada itu tidak kalau aku itu kita jadi apa asal ada itu apa itu habis itu kita mau nak apa sih dari itu kita nanti masa kita lihat itu nanti terus kita tak ada sih masa itu kita ini satu kita jadi hari tanah itu hari tanah itu adalah satu isu ya kalau kita lihat hari kita kan hidup ya malam ini anaknya waktu aku dalam itu apa ini bahwa kita hidup pun kita muda ini saya kalau ngomong, saya kalau ngomong saya thấy cho nên saya kalau ngomong saya kalau qua nãy giờ sao không có cái xe đấy em đi tập qua nãy trong cái gì mà em đi không được
No, I don't do that.
mà anh không phải
No, I don't do that. I don't want to relax. I seem to be. I told my kids they've grown up and they know that that's something they do by themselves. If you got wrong about it. Because that is something I always explain to my kids. So those are things that you will, if you want nice and those things, that you must buy it yourself. Because as parents, I can't do it. That is out of my
Okay. Thì có thể đã không có vô công đã có học thì có thể liên gì đó hãy xem cái xương hãy sẽ xương và cái cao cái cao gì đó hắn cái cao gì đó sẽ cái nhà tôi cũng có làm từ cái của cái ác công và cái pro thì để mà các bạn nhìn thấy
wise. It's very wise.
memang ada orang lagi kan itu kan tidak ada sih isu jauh apa nanti kalau tahu juga apa siapa itu ya kalau selamat mati kan karena sebelum kan sudah itu ini dia kita sendiri tak
Yes, that's what it is. Then you can give them. Yeah, we also do that. Yes, no, but we also do that. I also do that. So they do know what is acceptable. But I'm going to stop now, so. You also enjoy. Nice meeting you though.
Okay. Cảm ơn chị.
Yeah, you do come receiving.
Thank you.
Because some of the teachers do not have access to React.
Okay, so what would you like?
So now I think we should create a Google Meet for them so that
So if you can do that for me, I will do it. Okay, let's see.
do you have hand lotion?
Lotion, I'll find it out for you. I should have. I should be in. Okay, let's just see now. Umbrella. I don't know whether Meet is on here. No, Teams is on.
It's on Gmail.
Okay, so we can do that.
Yes.
I just
download.
Yeah.
Okay, because we do not have.
No problem. I will just put it in. I'm going to do this. I just want to check that I am on. I'm correctly connected. Can you see? Not there. I must be connected here. Control N. Yeah. Come on. Connections. 9 seconds. See, I need to do this first to be able to connect to it. But you can, okay, first go in here wherever you need to go. But you don't need that, you need to be off there, isn't it?
To go on Google and
No, but now you know, you don't use it
Yeah.
now.
create.
I am connected, I should be connected. But if I'm not, carry it box. All the stuff here. I'll just take off my. That's crazy.
Which one is yours?
I'm going to check it. Look at the ears. There.
Okay. So make sure Wi-Fi 8.
Good morning. I am on it.
Yes, you are.
Good morning. I'm just waiting to connect so that everybody can come in. I might have to go in. I'm going through Meet so that all the schools can connect. So I'm not missing you. I would love to be with everybody right now, but we just need to connect quickly so that other schools can connect. Thank you.
In 3 minutes.
Can I just lift this? Sorry then. For a minute, I lost my place. Okay. We have functions from it and try to make sense of it. So friends and students, if you don't mind, I just want to go through back again through some functions where we started the last time or where we stopped the last time. So while you are waiting for some schools, let me get started. Okay. Who can't hear? There's some schools that can't hear. Okay. So that's the functions last time. I spoke about, when I functions the last time, I spoke about the hyperbola. Now remember the line graph is not the one that I spent a lot of time on, because the line graph is the simplest one. We do that in grade 10, mostly in grade 9. So I didn't spend much time with it. But I spent a lot of time doing the parabola. So let's recap the parabola very quickly and look at all the things that we have to know about the parabola. First of all, the parabola can be written in standard form. Y is equal to ax squared plus bx plus c. Now the most important thing about the parabola was the following. Namely, that if you want to rewrite this parabola form, you need to know something about it. Namely, that it can be written into the form a x minus p all squared plus q. Now, when I explained the turning point formula, there was quite a few things that I explained around this. Namely, that to find this turning point formula, we could use the completing the square method. It's kind of like completing the square method. You can use it that way. But I also showed you a way to do it by simply finding the roots. Finding the roots of the equation. You add them up and you divide by 2. So that's the axis of symmetry, which is right there. The axis of symmetry is equal to x1 plus x2 divided by 2, and then one value you can find by substituting your axis of symmetry in your original equation, whatever your original equation is. So there was another way in which you could do it. I also showed you, ladies and gentlemen, how to find the equation of a parabola by using the root form. You have two given values that you kind of like work backwards when we find the equations in the root form. Now, very important around this, the interpretation of these graphs. What do we use it for? How do we use it? So when I talk about interpretation, we spoke about something called domain and range. Our favorite topics. Why domain and range? Because we get confused with it. And if I can come to the other side, I spoke about domain. How do we read domain? I said, we look at the x-axis, right? And we read from left to right. We read from negative infinity to positive infinity. I also say to you that if I look at any graph, how I get to know what the domain is, I ask myself a simple question. Does the graph pick up x values? Does the graph that I have pick up x values and it doesn't lose anything? There's no breaking in this graph. If it picks up x values all along and there's no break in the graph, it's continuous, in other words, then my domain will be x an element from negative infinity, because that arrow is continuing, which means it will always pick up x values from left to right, x element from negative infinity to positive infinity. That is how I say it. It could also be written as x an element of the reals. Now what do I mean? I say there must be no break in the graph when the domain. A good example would be if I have a hyperbola. So let's look at the hyperbola quickly. Just to show you what I mean, there must be no break. In other words, I have a graph that looks like this. So if I ask the question, does the graph pick up x values? Then simply, does the graph pick up x values? Yes, yes. But when I get to whatever the asymptote is in this graph, I cannot cross this line. I cannot cross that line. So let's call that line, let's say at the equation x equal to minus 1. Let's say the equation of that graph is x equal to minus 1. The equation of this graph is y equals plus 1. What's my problem? I can't cross over this line. So, in other words, I literally have a problem. So I said to you, then circle the problem. Circle it. Now we carry on. Is the graph picking up x values? Yes. It's picking up x values. Up that side, on the other side. Picking up x values. And it was coming on the other side. Sorry ladies and gentlemen, let me just do that very neatly. It's picking up x values. That doesn't look appropriate, so let me do it properly. There's my graph. Here's my graph going. And here we have my asymptote. So question was, does my graph pick up x values? Now let's have a look. It's picking up x values. Right. So the question is, does the graph pick up x values all the time? So from negative infinity, we go to positive infinity. Does the graph pick up negative values? Yes, 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 yes. Oh, there's a problem. But then I carry on picking up x values. So in other words, it will read x an element from negative infinity all the way to positive infinity, but we've got a problem, so exactly so. X is an element from negative infinity to positive infinity, but I'm going to cut out, so except whatever my asymptote is. Because if I remove the asymptote, then my graph will become continuous. My graph will carry on. So there is the domain. Again, we could write x an element of the reals. So that is what I mean. So it could be any graph, ladies and gentlemen. It could be a graph that does this. Let's say the graph goes like something like that. You have a graph that runs like that. So let's say this was a point minus 1. This was a point 2. If I'm in the domain of this graph, in this case I'm using very specific values. And I want to know what the domain is. So the domain in this case will read from minus 3, x an element from minus 3 until minus 1. It's round circles there, so it's not definite. Therefore I've got round brackets. Or x is an element from where to where? From 2 to 4. I'm not taking into consideration the space in between. And there you go. That's all. So I'm not considering that part there. That is what we mean. But we won't be bothered with that while you're at school. It does sometimes come up, but that's it. So that's what we mean by domain. Let's talk about range very quickly. Now range, similarly, we can have the same type of graph, and we're going to look at the same concept. What is range? Now you remember how I spoke about a range from the bottom to the top, from the earth to the sky kind of thing. Okay, how do I understand that concept? If I'm talking about range, ladies and gentlemen, then if I've got any graph, I'm going to look at the lowest point. So here's my lowest point. If I look at the parabola, use my axis of symmetry until where I go. This graph, let's say, at a certain point, so it won't be from my turning point. Y value is much lower than my y-intercept. So if I look at my range, it will start from minus 9. So does it pick up y values? Yes, it does. Remember that symmetry is my fold line, off. See, it's picking up. Does it ever stop? Now with my parabola, it normally has arrows on the end, so it doesn't stop. So y is an element from where to where? Definitely from -9 to infinity. Okay? Why definite, ladies and gentlemen? The graph turns over here. So there's nothing going on below. So that's how I see it. If I have an upside down graph, ladies and gentlemen, let's just have a look at the range again. If my graph is upside down and my turning point is now -1 and 10, what will happen now? Well, question is always, I'm looking for y values. Can you see I read from bottom to the top? So my lowest y value is -infinity, my highest value on the y will be positive infinity. Picking up y values. My arrows are going down. So, I'll pick up y values. Where am I ending up? I'm ending up y-intercept, ladies and gentlemen. Let's say that was 0 and 9, but at my turning point, the y value of my turning point. So it goes, y is an element from where to where? Square bracket, no, round bracket, because I'm starting from -infinity until 10 with a square bracket. That is how I put it down. Okay, so there is my range. Okay, lastly, what that I need to look at for you? Okay, let's talk about this very quickly. What was the range for an exponential graph? Well, the exponential graph is somewhat different, but all you have to look at is I ask the question, is there any graph at the bottom? Now, there's a graph at the bottom. So, it's y and 0. Right, so in other words, my graph starts at the x-axis. And the x-axis, another name for this is the line y equal to 0. But the hyperbola, in this case, is not hyperbola, the exponential graph in this case, I'm sorry, does not touch the x-axis. Therefore, y must be larger than 0. Okay? Doesn't touch this line. It's called an asymptote. If, ladies and gentlemen, I have the graph, I have an asymptote y equal to 1, and my y-axis is lower, then, ladies and gentlemen, this is what happens now. Larger than 1. I want you to notice carefully, this graph will pick up y values not for y lower than 0. Do you see? The graph is above my asymptote. So it will be for y larger than 1 because my graph will come closer to 1. So that was the main. Now again, like I said, ladies and gentlemen, we'll speak about this all the time, but it's important for you to grasp what we spoke about. There are 2 more graphs that I have to look at. I'm going to do it briefly so that you can have some understanding. So this was the basics behind the graphs. Now we need to combine them still. So what I'm going to do is I'm going to move on to the third graph, which happens to be the hyperbola. And what I'm really interested in doing is drawing it so that you all can draw it. And then you're going to do your exponential graph, draw it, and then I'm going to put it all together. So that's where I'm going. Hopefully, ladies and gentlemen, you do catch some of it, put it to practice, and hopefully it will make a lot of sense. By now, you should also have notes that I've made available to you with questions, lots of questions that you can ask, so that you indeed are able to work through some of the problems, make sure that you understand it, and also so that you have an idea of the things that you always ask. Now, when I look at the next graph, the third graph that we have to look at, now we've looked at the line graph, we've looked at the parabola. Now the graph I want to look at today is I want to look at the hyperbola. How do the graphs. What's the mother function of the line graph? Y is equal to LX plus C. What's the mother function of the parabola? Y is equal to AX squared plus BX plus C. And this one, Y is equal to A over X plus B plus Q. Now, ladies and gentlemen, if I have highest power of X is 1. If I have a regular, highest power is 2. If I have a, I will slow down. Okay. If I have a hyperbola, the highest, the X is in the denominator. Okay? Don't worry, I'm still recapping. I'm only going to start teaching now. Okay? I'm only going to start teaching now. So, we've got the line graph, the regular, and I'm going to go to the third one today. So what's important, ladies and gentlemen, is now you're going to start writing. We haven't anything that you could write yet. You're only going to start writing now. So, in the first one, line graph, highest power of X, 1. Parabola, highest power of X, 2. So it doesn't matter, ladies and gentlemen, if you've only got 2 terms. If one of the terms is the highest power of X2, you're dealing with a parabola. In the case of hyperbola, you have your X in your denominator. That's one way of writing it. There are other ways of writing it as well. It should show you it can also be written as this way. X minus P, X minus Q. Let's not use P and Q. Let's use another letter. X minus A, or make it D, and X minus G. Can also be written that way. Now we will look at both forms so that you can find out how to do it. So what am I going to do right now? I'm going to look at the hyperbola, and all we're going to do is we're going to draw it and explain to you how we go about the hyperbola as a graph. So let's see. Let's talk about hyperbola. And some of you might say the word hyperbola. Okay, so let's look at hyperbola. Well, the first thing that I noticed when you came from grade 10, this was the equation that you used. Y is equal to A over X. Alright. Your teacher would have told you, or you would have worked it out, that you would get your graph in 2 quadrants. It either looks this way. Don't write please, this is for revision. If A was negative, then your graph would lie in the second and the fourth quadrant. If A was positive, your graph would lie in the first and the third quadrant. That is what you did. Okay? In grade 10. So an example of this would be Y equal to 2 over X. That was an example. That was what you did in grade 10. What we are going to do, ladies and gentlemen, is we're going to explore it. We're going to shift this graph up and down. We're going to change the asymptotes. It's no longer going to be the x-axis or the y-axis. That is what we are going to do. So you didn't have to write this down. We are going to start from scratch so that you understand it carefully. So let's look at the hyperbola the way it should be given to you. Now, let's have a look. How do I draw a hyperbola? And by comparison, you will be able to understand. Okay. So, Y is equal to 2 over X. Let's draw it. Let's draw this graph. So what did we do? We said, draw a table for me quickly. Let's draw the table. That will just give us a little bit of an edge. We're not always going to draw a table, but for this moment, let's draw a table. So let's make it minus 2, minus 1, 0, 1, and 2. Let's draw the table. Other words, ladies and gentlemen, let's substitute X values into here. Okay, so I'm going to just put a column on the side and I'm going to do the substitution for you. Right, so Y is equal to, if I substitute the first value of X into here, so the first value of X happens to be minus 2. 2 divided by minus 2 gives us what? Y will then be equal to negative 1. Now 13. The next value of x is going to be negative 1. So 2 divided by negative 1 gives me negative 2. The next value that x is going to take on, 2 divided by 0. Anything divided by 0 is undefined. You see? Undefined. We don't know where that is. Next one. Y is equal to x now takes on the value of 1. So it's 2 divided by 1, which gives me 2. Last one. Last value x. 2 divided by 2, and I end off with 1. So there are my values that I am going to have for my graph. So I draw my graph, y equal to 2 over x. So what do I plot? Negative 2, negative 1. 1, 2. Let's see. 1, 2. Let's make it another value. 1, minus 1, minus 2, and minus 3. So let's plot it. When x is minus 2, where is y? Yes? Where am I now? Minus 1. Minus 2. Can you see where we're going, ladies and gentlemen? When x is minus 2, my y value associated with it is minus 1. So let's see, it goes through that point and that point. So I know it's going this way. See? Let's draw that curve very nicely. And just put my points a little higher. Minus 2 and minus 1. So it goes through, when x is minus 2, it goes through minus 1. When x is minus 1, goes through minus 2. So my graph is going to do something like this. Just have a curve. Notice it won't touch the x-axis at all. Okay? That's basically what it does. Okay, when x is 1, what happens to y? Y then becomes 2. When x is 2, y becomes 1. So there we go. There's my graph. Notice, not a block, but I indicate that it's moving towards my x-axis. It moves towards my x-axis. Okay? There's my graph. Notice, like I said, A was larger than 0, so my graph is in the first and the third quadrant. I name my graph. Y equal to 2 over x. So that's what I did in grade 10. Now there's a reason why I use my table, because this graph, if I find the x-intercepts and the y-intercepts, it's not really going to help me. So I use my table. Just a minute. What's it? I just want to see what's the teacher. Okay, so let's carry on. So now let's look at our first graph. And the first thing I'm going to look at is I'm going to look at the graph y is equal to 2, and in my divisor I'm going to put x plus 1. Right. In other words, I'm first going to look at maybe I should first look at a vertical shift and not horizontal. Let's look at what is a vertical shift first for you. Oh, it's not me.
It's you.
Is it me?
Just put it.
Good morning. Yes. Look, I can't talk to you. I can't talk to you now. I'm in a class. I'm teaching. I said after 4. I'm in a class, sir. Okay, here we go. I've got my equation, and what I'm going to do is I'm going to look at a vertical shift. Now, how do I know I've got a vertical shift? because I'm adding on a value to my graph. Now, let's use a table and use the x-intercepts. Now, and the y-intercepts. I'm only using the table at the moment, ladies and gentlemen, so that we can find our feet. We don't normally use the table because of the time that it consumes. Okay. Now, normally what we say is normally would say x-intercept, set y equal to 0. And y-intercept, set x equal to 0. So using my table again, ladies and gentlemen, what am I going to do? I'm going to substitute for x. So y is going to be equal to 2 over negative 2 plus 1. So what do we get? 2 divided by negative 2 gives me negative 1 plus 1. So y in this case would be equal to 0. So I get 0. Next one. If I substitute for x, I'm going to substitute negative 1. So 2 divided by negative 1 plus 1. So y will be equal to negative 2 plus 1. So y will be equal to negative 1. Now ladies and gentlemen, I'm substituting so that you can see where I'm going. What is happening? The next value for x that I need to substitute happens to be 0. Y is going to be equal to 2 over 0 plus 1. Now, anything divided by 0 gives us what? Undefined. Undefined. Because I can't have 0 in my denominator. Doesn't matter what I add to it, it remains undefined. x1. Y is equal to x is equal to 1, so sorry, not 1. 2 divided by 1 plus 1. And I end up with y is equal to 2 plus 1. So y will be equal to 3. Next value of x. Y is equal to 2. So, my x is equal to 2. 2 divided by 2 plus 1. So y will be equal to 1 plus 1. So, y will be equal to, let me just see if I can make a mistake. 2 plus 1, y is equal to 2. And that will give me 2. Now, let's see if I can plot this graph. Just to help us along. So, minus 1, minus 2, minus 3. Yes? Okay. Two, 3. Okay, so let's plot the points. When x is negative 2, y happens to be 0. When x is negative 1, y happens to be negative 1. So there they come. The next one, when x is 0, y is undefined. So this line I can't use. When x is 1, y happens to be 3. When x is 2, y happens to be 2. Okay, let's just use another point to see what happens. What if x is going to be equal to a half? Let's try when x is equal to negative a half. Plot that one in, let's see what happens. If I take negative a half, let's use our calculator. X is equal to negative a half. Let's see what we get. So I'm just going to write it up here. So y is going to be equal to 2 divided by negative a half plus 1. 2 divided by negative a half will give me, I'll do it the long way for those of us that are all together, plus 1. So I end up here with negative 4 plus 1, y will actually give me negative 3. So x is negative a half, I'm going to negative 3. Let's try negative 3. Sorry, this is wrong. Should be here. I'm putting negative a half. Oh, sorry, my axis. Okay. Let's try negative 3. I substitute negative 3 into here. I can put negative 3 there. Negative 3. Let's put negative 3 in here. So y is going to be 2 divided by negative 3 plus 1. Negative 2/3 plus 1 will give me positive 1/3. The coordinate pair here would be 1/3. What am I trying to show you, ladies and gentlemen? I'm trying to show you that this graph will do this. It will curve in that way. That seems to be the problem. Oh, people coming in. Okay, so that's what my graph will do. It will kind of like curve in this way. Notice, this is point by point plotting. So this point here, negative 3 and 1/3. This point over here, minus 2 and 0. This point over here, minus 1 and minus 1. Okay, this point here, negative 1/2 and negative 3. You don't need all those points. All I'm doing is just trying to show you how this graph is changing from what you initially had in grade 10 to what you are having now in grade 11. So I've added 2 more points to my graph. I've added negative 3 and I ended up here with positive 1/3. Okay. I've also added the point negative 1/2, which I should have put in here. And I ended up with negative 3. Just to show you how this graph looks. The next point that I'm going to look at, I've already got 1 and 3. And I've got the other point, namely 2 and 2. But I will see 3 and see what happens. What happens when I have 3? So when x is equal to 3. So can I take off this one? What happens if I substitute x equal to 3? So you have to substitute x equal to 3 on this side. Let's see. So y is equal to 2 over 3 plus 1. So I actually end up here with 5 over 3. That's for 1. So 5 over 3 would give me, looking at 3, I end up with 5 over 3. So that's just fast. There's 3 there for 5. So there's 3 and 5 over 3. So what's my graph doing? My graph is doing this. Now what is amazing, ladies and gentlemen, if you look very carefully, this graph is going to move towards the line y equal to 1. This graph is moving towards the line y equal to 1. It's not going to cut the line y equal to 1. Why not? Because the line y equal to 1 is the asymptote over there.
The schools are taking notes, so they're saying that you fast, so please don't immediately
Erase.
because they're taking notes.
Okay, now I won't erase because they need this.
Yes.
Okay, so the asymptote here is y equal to 1. The graph cannot touch that line y equal to 1. I'm going to give you an opportunity to write so that you can see what has happened. I need to put the third one on and I can't put the third one on. You need to see the vertical shift first. So all that I've got on my board is, ladies and gentlemen, using the table method, getting from grade 10 to grade 11, I've shown you how to do a vertical shift. And the vertical shift, I've given you the substitution for those of us that are struggle with how we get to the x values, the y values rather. I've kept it for you. I've plotted all the points for you so that you get it from. Okay? So there they are. So please, I'll give you 5 minutes to write it down. You can stay.
It's fine, I just want to
all there? Can we start? Tell me, are you ready? Can we start? Have you written down? Okay, so let's carry on. So I have now done. Please indicate if you're ready, then I can take this off. Not ready yet. And guys, you must tell me whether I can go on or whether I must wait. Okay. Alright. Okay, here we go. So now you've seen what a vertical shift looks like. Now normally we would just look at the x-intercept and the y-intercept. So this graph, ladies and gentlemen, has moved up by 1 unit. From my original, it's gone up by 1 unit. Now we're coming back to that. I'm going to come back to that graph. I just need to put one more on and then you'll be able to see what I'm trying to show you. Okay, so let's look at a horizontal shift. What does a horizontal shift look like? So let's try the graph. Y equal to 2 over x minus 1. Let's try that particular graph. Now again, ladies and gentlemen, usually we will find the x-intercept and we will find the y-intercept. So we're not going to use the table all the time, but just for this round, I need us to use the table. Okay. So again, we can have the same points, -2, -1, 0, 1, and 2. Same values. Now, again, I'm going to plot my graph, not so skewed though. Alright, so, when x is equal to -2, so y is going to be equal to 2 over -2, -1. What do I end up with? Y is going to be equal to 2 over -3. So y is going to be equal to -2/3. Next value. When x is equal to -1. So 2 over, value of x that we have now is -1. So I've got -1, -1. So y is going to be equal to 2 over -2, and I end up with -1. Isn't that interesting? Following to the next one. Y is equal to 2 divided by 0 minus 1. When I add 0 to anything, I remain with the anything. So y is equal to 2 divided by -1, and that gives me -2. Now, ladies and gentlemen, this is a very important one because here students often get confused. 0 minus 1 gives me the -1. 0 added to anything gives me the anything. But when we have 0 in the denominator, okay.
No, we can only see a half of the board of the graph which we're about to draw.
You need to mute your mic and write all your comments on the comment section and just pin your screen for the full screen. I just wrote it on the chat box.
Okay, so perhaps I should go over from the other side. Let me just do
it. Shows everything. It just needs to pin it.
Okay. Let's carry on. Sorry about that, everyone. So, please note that when we divide by 0, we don't get +1. Okay, sir?
Oh, it's fine.
Okay. You get, when we divide by 0, doesn't matter whether you add on something, you still get infinity. I undefined. Okay. So here we're going to get -2. Okay, the last one that we must add, we're going to add, is I'm going to have 2. No. I'm going to add 1 now. Sorry, I've got the wrong one. Okay, I did 0 now. Sorry. Y is going to be equal to 2 divided by. The next value for x that I'm adding here is 1. So 1 minus 1 gives me what? Oh yes! Now I come to 2 divided by 0. Anything divided by 0 in the denominator gives me undefined. There we go. Last but not least, y is equal to 2. X is equal to 2. So y is equal to 2 over 2 plus 1. And I'm ending up here with 2/3. There we go. So just like the first one. So let's put all our points in. Sorry. That's a bit rough, eh? Okay, are we there? So let's see the highest point that I'm going to, I don't go more than 3, I don't think so. Okay, that's on the y-axis, -1, -2, -3. Now ladies and gentlemen, let's plot our points. Again, when x is -2, y has to be -2/3. So let's divide the space between -1 and 0 into 3 parts. So it's -2/3, which is 2 places part of that. So there's -2, your y value is -2/3. So -2 and -2/3. Next one, that's my first point. I'm going to have -1 and -1. So -1 and -1. Notice I'm just doing point by point plotting, just to illustrate to you what happens. When x is 0, y is -2. My golly. So this plot does cross, it can touch the x-axis, it can move onto the y-axis. I didn't know that, did you? Well, we're seeing something now. What happens when x is 1? Oh, there's a problem. I have a problem now. When x is 1, the graph becomes undefined. How do we indicate undefined? Notice, remember from, if you've done your 3 graphs already, undefined is indicated by an asymptote only, and this asymptote has got a name, and here is the one x equal to 1. Next point that we have, when x is 2, y happens to be 2/3, and I join my points. 2 and 2/3. Let's take another point just to help us along so we can get more points to plot this one, because here I know exactly what's happening. I can draw the graph. It's going to come closer on this side. I'm not so sure how to draw that side. So let's put in here 1.5 and time calculators together. So the y is equal to 1.5. X over 5. 1.5 minus 1.5 minus 1, so let's see. No, I lied. Positive 1.5. 2 divided by 5 or like divided by 4. Those of you that are stuck, I'm taking now half, I'm finding another point, so I take 1.5 and I substitute it, then I'm going to get a half. 2 divided by a half. So 2 is a whole number divided by a half. So 2 remains, the divide line becomes a multiply and the half inverts, and that's where I get 4 from. So this is a half and 4. That's my point. And now I know that the graph is going to move closer and closer to the There we go. There's this is the horizontal shift. So ladies and gentlemen, what I've done, we've done horizontal. So we've done a vertical shift, the graph is moved up, and we've also done a horizontal shift. Okay, so that's what I want you to see. Please write quickly so that we can move to the next one. But this is the most important thing. So compare, we now have a graph that moves horizontally, and we have a graph that can move vertically. And we need to talk about these two graphs, but I first need you to understand how I plot these graphs, so that you can see where it comes from. Notice when I substitute, ladies and gentlemen, I draw a column on the right hand side of the page. I substituted my values of x, I've done the hard work to show you what changes and what doesn't. The points where you notice, naught plus something gives you the something. But when you divide by 0 singularly, when you get 0 in the denominator, doesn't matter if you add on things, like in the case of the vertical shift, it remains undefined. How defined? With and I was silly, ladies and gentlemen, I should have shown already that when we have an undefined in your y value, that line becomes an asymptote. So in this case, the name of the line x equal to 0. This y here is the line x equal to 0. That is an asymptote. On this side, x equal to 0 is an asymptote. On this side, x is 0 is also a y. X is not equal to 0 is an asymptote. X equal to 1 is an asymptote. This one, y equal to 0 is an asymptote. Because the graph does not touch. This line, y equal to 0, is graph does not touch this line. Graph will close here, but that it won't touch it. Okay? Right. This one over here. Now, I need you to do something for me quickly. Am I telling you the truth? Is it really an asymptote? Is it really an asymptote? Really, am I telling you the truth? I want you to check some for me. What is an asymptote? An asymptote is a line the graph cuts. I want us to take our calculators and check for me if I'm telling the truth. Are we ready?
But you don't listen to us when your questions was. Oh, miss. Miss. Like really now?
Alright, can I continue or with what we are doing? I want you to check for me if I'm really telling the truth about that, because I need to talk about that word, what an asymptote is. You must tell me if I can continue or whether I must wait for you. Do I have to wait or can I continue? Okay. Okay, so now, as I said, we've done a horizontal shift, we've done a vertical shift, and now we need to learn and understand this word asymptote. So x-intercept, y-intercept, those are words that you know already. For this illustration, I'm not using the x-intercept, the y-intercept, because I first want you to understand where I get my points from, how I draw this graph, before we explore this graph and do it in much simpler ways. Okay, with only using 2 points. Okay, may I continue or must I still wait for you? Okay, now let's have a look. Ladies and gentlemen, I would like you to substitute negative x equal to negative 4. I want you to put negative 4 into my equation here. So substitute negative 4. Tell me what you get. 5, what do you get? You get the right answer, or you getting the same that I get, 2 divided by negative 5, you're going to get 0.4, or you're going to get negative 2 over 5. So I'm getting 0.4. So 0.4 is less than a half. So the next point will be a half. Now I want you to put in 10. Let's put in negative 10 here. Tell me what you get. So if y is equal to, if x is equal to, what did I say, 4, negative 4, then y is equal to negative 2 over 5. If x is going to be equal to negative 10, what happens? So let's see what happens if I have negative 10. So then it becomes 2 divided by negative 10 over negative 11. What's happening, ladies and gentlemen? I get something like 0.18. So if x is equal to negative 10, y is equal to 0.18 recurring. That's what I'm getting. Right, the next value, let's introduce, instead of using 10, let's use 100. Let's use 100. What happens if I use x equal to negative 100? What will y be now? Notice I'm using my calculator, I'm substituting in here, so x is equal to negative 100. So now I get 2 divided by negative 101. And I get 0.0198. Let's divide it by 1,000. Let's make x equal to 1,000. X is equal to negative 1,000. So I'll say 2 divided by, so I'm using 1,000 minus 1. I'm getting negative 1,001. 2 divided by 1,001. I'm going to get 1.9. X equal to 1,000, negative 1,000, and I'm going to get y equal to 1.9 times 10 to the minus 3. So I'm going to get a very small number. What is happening, ladies and gentlemen? The point behind what's happening there with these numbers is, as my x value becomes smaller and smaller and smaller, my graph is moving towards this line. It's moving towards the x-axis, the negative x-axis. The y values are becoming smaller and smaller and smaller. But can you see, ladies and gentlemen, it doesn't touch this line at all. And that is where we get the word from, asymptote. We can test it on this side as well. Let's test it. And don't write it down. All we want to do is we want to test it and see whether we're telling the truth. Whether this line, the y, the x-axis in this case is really an asymptote. So let's try x equal to, let's make it 5. X equal to 5. What happens if x is equal to 5? I'll get 2 over 5 minus 1. So 2 over 5 minus 1 is 2 over 4, which is a half. So this graph will now touch a half. When x is equal to 5, y will be equal to a half. If x is equal to 20, what will y be? So y is equal to 20 minus 1, I'll get 2 over 19. What is 2 over 19? Let's see what 2 divided by 19 gives me. It gives me 0.1. Y is equal to 0.1. Let's take x equal to 50. What happens now? I'll get 50 minus 1, which is 49. What is 2 divided by 49? 2 divided by 49. I end up with 0.04. What can you tell me now, ladies and gentlemen? Can you see that as my x values as they are becoming bigger and bigger and bigger, as I'm moving to the right, what is happening to my y values? They become smaller and smaller and smaller. You see? They become smaller and smaller and smaller. Sorry, this is 0.0. 0.04. It's becoming smaller and smaller. Here at a half, or 0.5. There at 0.1. There at 0.04. So to become smaller. It's not going to touch this line. And that is where the word asymptote comes from. So ladies and gentlemen, you've now heard a new word. The line y equal to 0, also called the x-axis, is an asymptote. What does it mean to be an asymptote? The graph or the function does not touch this line. We can do the same for this graph. This graph, which line won't it touch? Won't touch the line y equal to 1. Now, let's test it. Let's test it very quickly. I have my equation, y equal to 2 over x plus 1. Let's put in a value for x. Let's say that I'm going to call x, we know we have 3 over 5 over 3. Let's say if x is equal to 10. Let's say, what is 2 divided by 10 plus 1? Please, you must be doing this on your calculator, not writing in your book. All I want to see is, can you understand what we're talking about? I'm going to get, if x is equal to 10, this one is dry, sorry. X is equal to 10. If x is equal to 10, then my y, sorry about that, 2 divided by 10 plus 1. And I end up with 1.2. Let's make x equal to 100. What happens? 100? 2. If I got x equal to 1,000, what do I have now? X equal to 1,000 plus I add that 1, what happens? I end up with, if x is equal to 1,000, I end up with y being 1.002. What can you tell me about those numbers? Can you see that my y value, ladies and gentlemen, is hovering over a particular number? Which number is it hovering over? Notice carefully. There's a 1, there's a 1, there's a 1. I'm getting bigger and bigger with my x values. I was at 10, I was at 100, I was at 1,000. All these are getting smaller and smaller. It's all moving towards this line y equal to 1. But it doesn't touch the line y equal to 100. So it's doing this. If I can redraw it for you. I have the points 10 on here. So let's say I'm looking at 10. This is 10. Let's just start at 10. If I'm at 10, then the graph is kind of like saying, let's look at 1 there. If that's 1, let's say, I'm just going to be above 1. At 10, it is just above 1. 1.2. At 100, let's make 100 over there. It's just going to go slightly below 100. At 1,000, ladies and gentlemen, it will also go lower down. Ladies and gentlemen, it won't touch the line. In other words, if I draw this line over there, can you see it's moving closer and closer, but it doesn't touch the line ever. It moves closer and closer and closer to the line. That is what I'm trying to say. Everybody with me? So that is what's happening. So when it's 10, I'll get 1.2. When it's 100, I'll get 1.02. When it's 1,000, I'll get 1.002. So it's moving towards this line, y equal to 1. But it doesn't touch the line. And that is what we mean, ladies and gentlemen, by an asymptote. So what's the asymptote for this graph? For this graph, the asymptote is the line y equal to 1. For this graph, where's the asymptote? When it's the x-axis, yes. Y equal to 0 is the x-axis. Asymptote in this case. Is it y equal to 0? Yes, that's the 1. And the other one, most importantly, that the graph does not touch is this line, x equal to 1. So this is very, very important. Those are my two asymptotes in the space. So the line that this graph doesn't touch is the one x equal to 1 is my horizontal asymptote in this space. So this one is my horizontal asymptote because the graph moves towards this line. So that one is the one asymptote, but this one is also important. So this is my horizontal asymptote. Can you see the word horizontal? Not horizontal, sorry. I'm getting a bit mixed up here. This is my vertical asymptote. This one I must take note of. Now why do I call this my vertical asymptote? Can you see that this one cuts the x-axis? Let's see. Does it cut the x-axis? Let's have a look. Bingo. Does the graph move towards it? Yes, of course. We use smaller values. Didn't we use smaller values? Yes, to see where it went to. So, this is my vertical asymptote. What is this one? This is my horizontal asymptote. Now, let's show you where this is. So, this is on the y-axis. This is where you're going to find all these things, ladies and gentlemen. So, you need to put those words in. Your vertical asymptote cuts the x-axis. Your horizontal asymptote cuts the y-axis. Next step. If I look back to my equation, ladies and gentlemen, where can I see the vertical asymptote in my equation? Come. Where do I see it? If I compare this to my equation, let's go back to my equation. I'm still at the graph, I'm going to my equation where? Is it on the left hand side? No. Is it in the numerator? No. Is it in the denominator? No, ladies and gentlemen. Let's have a look. If I format of this x equal to 1, isn't that very similar to what is in my denominator? So what is in my denominator gives it away to me, ladies and gentlemen. In other words, right from the beginning already, I can find my vertical asymptote by looking at the denominator. How do I move from x minus 1 to x equal to 1? Well, very quickly. I take the x minus 1 and I set it equal to 0. And lo and behold, x is equal to 1. And that is how you find your vertical asymptote. In other words, you can draw it immediately and have your vertical asymptote. Okay, shall I say that again? Ladies and gentlemen, I state the following. We have a vertical asymptote. It is a line the graph does not touch. A very important one. This one is an asymptote, correct. But the very important for me is the vertical asymptote and the horizontal asymptote. So the vertical asymptote cuts the x-axis. Because it's got an equation, x equal to 1. So my question was, if I take this x equal to 1 and I compare it to my equation, where do I see it? Something similar to it. I don't see it on the left. I don't see it in the numerator. I see it on the denominator. So, don't put it in it. You've got to put it in. Because then when you look to me. It's in the denominator. It's in the denominator, so in other words I ask, how can I rewrite it? In other words, I take the denominator, I set it equal to 0, and I solve. There we go. So that's how I find the asymptote on the y for my graph, the vertical asymptote for my graph. Just look at the denominator. Make it an equation by setting it equal to 0, and I can find it immediately. Right. What about this one? Let's look at the asymptote here. My asymptote is a horizontal asymptote. What does it cut? It cuts the y-axis. That's the y-axis. If I look at my original equation, where do I see y equal to plus 1? Well, is it on the left hand side? No. Is it on the right hand side? Let's look at the numerator. It's not there. This one, no, it's not beneath it. I see. It's the add-on. So there it is. My horizontal asymptote is the add-on. So the add-on is my horizontal asymptote. This is where I get it. It's my horizontal asymptote. The add-on is my horizontal asymptote. So when I add on something, I'll be able to get my asymptote. So ladies and gentlemen, in a nutshell, where do I get my asymptotes from? The one asymptote is found in the denominator, the other asymptote found with my add-on. Okay. 1 minute to make sure you've written in those words, and then we can take it off, and then we'll start drawing one where both of them are in. Okay? Tell me when you're ready. From the table, and we're going to learn to plot this graph without using the table. You only need 2 points to draw it. Okay? 2 points to draw the graph on the one side, and 2 points to draw the graph on the other side. This is in grade 11, and I've shown you how the graph looks using only the vertical shift, only the horizontal shift. Now we're going to go to one where it has both the vertical and the horizontal shift. So let's tackle that particular one. So let's look at the equation. Y is equal to 2 over x plus 1 minus, let's put it this way. Maybe I should put, I don't want to use the 1 there again. Let's make it minus 3. Plus 3. Minus 1 plus 3. I want the numbers to be different so that you have some understanding of what it is all about. Okay, let's see. Now, ladies and gentlemen, the first thing that I need to do to draw the parabola. To draw the parabola, hyperbola. Draw the hyperbola. I need 2 things. I need the asymptotes, and I need the x and y intercepts, and perhaps, and maybe 2 pairs of coordinates. Okay, just for now, maybe 2 pairs of coordinates. So what do I need? To draw this parabola, I need to know where the asymptote is. So what do I do? Like I said earlier on, I said to get the horizontal asymptote, I look to the add-on. to get the vertical asymptote, I look to the denominator. So where's my vertical asymptote? First thing that I have to look at, if I rewrite my problem quickly, y is equal to 2 over x plus 1 plus 3. So this part over here, this gives me my vertical asymptote. Sorry, this thing is not happening quickly. This part over here, this gives me my vertical asymptote. This part over here, with the sign add on, this gives me my horizontal asymptote. So there is where I find everything. And those are the very first things that you draw onto your graph. So what do I do with my vertical asymptote? I say x plus 1 equal to 0. I change it into an equation which gives me x equal to minus 1. There's my vertical asymptote. This one over here, as it is, y equal to 3. That creates my horizontal. Sometimes in the exam, they say a over x plus p plus q. And the poor children struggle, oh my goodness. What is p equal to? I always say to the learners, take this. X plus p is equal to 0, so x is equal to minus p. Here you can see clearly what you must do. So, if x is this, then minus 1, that's a minus 1, so x is going to be equal to minus 1. So what must I write over here? X plus 1. So x plus 1, according to them, must be p. Because they don't know the value of p. And now they stuck. But by comparison, they can see that my p value according to this must be 1. What is p's value? Positive 1. How do I know? I set this thing equal to 0. By comparison, here, x is equal to minus p, x equal to minus 1. There's a minus, so p's value happens to be 1. And that's what I did. So that's where the learners get confused. They're not so sure, can it be done if they give me the standard form of hyperbole. Yes, ladies and gentlemen, it can be done. Even if they give you the standard form. So now I'm going to draw my graph. Okay. Remember I said x intercepts and y intersects. The first thing that I needed was my axis of asymptotes. So there's no axis of symmetry here. So the first asymptote that I got was the one that's vertical. So let's put them in. Minus 1, minus 2, minus 3, 1, 2, 3. X-axis. 2, 3. And remember, we don't want a massive graph with all the coordinate pairs. We just want to be able to see it. So my asymptote is at x equal to minus 1. So just for a minute, forgive me here, equal to 1. So x is equal to minus 1. My y asymptote or my horizontal asymptote is at y equal to 3. So now I draw in my dotted line y equal to 3. There it goes. Everybody happy. Now that I've got my asymptotes, I more or less have an idea where my graph is going to be drawn. Which quadrants? The first and the fourth, first and the third, because my A is positive. A happens to be positive 2. Right, now, let's have a look. The x-intercepts. What do I do when I have x-intercepts? I'm going to do x-intercepts the way you've done it before. What do? We set y equal to 0. Like you know how to do it, I've done it before. So 0 is equal to 2 over x plus 1 plus 3. If this section was a negative 2, you would have taken it to the left hand side. The positive, don't move it. 3 goes over to the other side. So it becomes 3 is equal to 2 over x plus 1. 3 is a whole, so it becomes a fraction over 1. I can now, therefore, cross multiply. Okay? So 3 plus 1 is equal to 1 multiplied by 2. That's what it means. The denominator on the left hand side multiplies by the numerator on the right hand side. The denominator on the right hand side multiplies by the numerator on the left hand side. Exactly the way you did it in grade 9. So 3 multiplied by x is 3x. 3 multiplied by 1 is 3. 1 multiplied by 2 is 2. And 3x will now be equal to 2 minus 3. 3x will now be equal to negative 1. Divide both sides by 3, x would now be equal to negative a third. Now, there's my x-intercept, ladies and gentlemen. X-intercept only 1. Written as a coordinate pair, negative a third and 0. There it is. On the x-axis, x-intercept equal to 0, so y is 0, if the point will be on the x-axis. So again, I'm going to divide the space here into 3 parts. There's 1/3. So negative a third and 0 is my coordinate pair. I put it on the x-axis. The last part, y-intercept, not the second last part, y-intercept, I'm going to set x equal to 0. So I set x equal to 0, so what happens? Y is equal to 2 over 0 minus 1 plus 3. Y is equal to 2 over minus 1 plus 3. 0 added to anything gives me the anything. So y is equal to negative 2 plus 3. So y is equal to positive 1. Written as coordinates, in case they ask you, the value of x for a y-intercept is always 0. The value of y is 1. Any coordinate pair which has the x value 0 is found on the y-axis. So 0, 1. There he is. He is found on the y-axis. So now I can draw my graph. Now I did say, ladies and gentlemen, we need 2 more pairs of coordinates. In other words, I basically know how this graph is going to look. But perhaps you're not so sure. Okay, because this graph has shifted. So it's not exactly clear why it's in the 4th quadrant now, or why it's looking the way it looks there. So let's look at 2 other pairs of coordinates. Let's put in other values. Let's put in, shall we look at a value like x is equal to, let's put in a value like x is equal to minus 3. Just for your sake, let's say x is equal to minus 3. What happens if x is equal to minus 3? Therefore, y will now be equal to 2 over negative 3, negative 1 plus 3. So y will now be equal to 2 over negative 4 plus 3. In other words, y will now be equal to, that's a half, it will now be equal to 2.5. So when x is equal to negative 3, y is 2.5. It's negative 3, y is 2.5, positive 2.5. Positive 2.5. Okay, so it's about there. Negative 3 and 2.5. Now we already know where to draw a point, but I'm not so sure. So I'm looking at it. Let's say I take a number like 4. What happens if I make x equal to 4? Negative 4, sorry, negative 4. So y is equal to 2 over negative 4, negative 1 plus 3. So this is going to give me negative 2/5 plus 3. This is going to give me 3 no, it's 2 and it's going to give me 2 and 3/5. 2 and 3/5. That's 2 and 3/5. 2 and 2/5, 2 and 3/5, so it's a little bit higher. No, that one is a little bit higher. So it's a little bit higher, but it doesn't touch that line, so it's coming this way. Let's choose a number. I wonder if I'm 100% right today. But ladies and gentlemen, this is what's going to happen. I'm going to draw my graph through my 2 points. There it goes. Okay, now to get the other points on the other side. Let's just get my points on the other side. I think I've got something wrong there somewhere. It's minus 3, it's minus 4. It should be above the line, plus 3. Okay, so I have got 2.5. It's not going over. It's going to go, that's the one that I've got. I hope I haven't made any mistakes. You know what? Ladies and gentlemen, I do apologize. I did make a mistake. The graph here is x minus 1. I'm wondering why my graph's in the wrong quadrant, and I'm not thinking. I did make a mistake, a very big mistake. When I swapped it for you, I did not swap it back. This must be minus, this must be minus. Sorry, ladies and gentlemen. This must be minus. My fault, actually. See, I made this plus. The graph is in the wrong quadrant for you. So it's minus, minus 1, minus 1. This gives me positive 3. No, this is minus 3. Positive 3. Can you just correct it for me, please? This is 5 over 3. 5 over 3. And this gives me 5 over 3, not 1. That one is right, 0, 1 is right. Let me just see. Let me see it right now. Please do check that I didn't make a mistake. The other mistake that I made is I didn't put the minus sign in here. I'm really up the pole today. It's minus 3. It's minus 1. It's plus a third. It's positive a third. It's positive a third and 1. Positive a third and 1. It's not much difference, eh? No, I think I'm wrong. X is equal to... Hey, my whole graph is wrong, guys. Sorry, my silly mistake. I don't know what. You know what I'm going to do? I'm going to change it here. I mean, that won't be such a big deal. Change it to x plus 1. Let's work with that one. Since I've done everything for x plus 1. X is equal to minus 1. Let's change the equation rather. So make it plus here. Then it doesn't make everything upside down. So let's just leave it. So x is equal to minus 1. That's correct. So minus 1 plus 3. There's the minus 3 that must be there. Because positive 3 goes over to the other side, it becomes negative. Because negative 3 multiplied by x minus 1, negative 3x. Positive 1, positive 3 is right, equal to 2. So negative 3x minus 3 will give me negative 3x minus 1. So x is going to be equal to positive a third. Positive a third is right. Then my y-intercept, I'm split up this. Sorry, ladies and gentlemen, my apologies. Somewhere I'm sleeping today. Okay? And that is just wrong. So here, 2 over minus 1, 0, plus 1, 3. Okay, so now it becomes minus 2 plus 3. Give me positive 1. So 0, 1 and a third. 0, 1 and a third. And a third. It still doesn't make sense. I am really up the pole today. I must change all of that stuff. Oh my word. All of that stuff must be changed. This is 5. 5. I thought so. See, my graph is in the wrong quadrant. That is how I'm able to diagnose where my mistake is. 4, 5. So I say, ladies and gentlemen, if you made a mistake, you can actually go back because my graph can't be drawn in the wrong quadrant. It was drawn in the wrong quadrant and I can see that it's wrong. It's still giving me a graph in the old quadrant. Okay, let's just check now if I've done it correctly. Okay. If I use 1 equal to 2 over x plus 1 plus 3, so it's minus 3 over, it becomes plus here. It's plus, it's minus, that goes plus, it's 5, it's positive 5 here, it's minus 5 over 3, it's minus 5 over 3, and that one is x-intercept is minus 5 over 3, yes, now it's right. Remember I said if A is positive, A is larger than 0, where's my graph? In the first and third quadrant. What did I have on the board? I had a graph in the fourth quadrant. And that is why I realized I made a mistake. So 0 and 5 is here. So even though we practice these things, it can happen. So negative 5 over 3 is 1 and 2/3. 1 and 2/3. So it's past here. It's almost at 2. So I had to work a little bit more. Just before 2, there's my x intercept. Now, how must I draw this graph? How is it possible for me to know which direction this graph moves? Now, very simple, ladies and gentlemen. You can either go and find more points, or you simply draw your graph around and must move from the asymptotes towards the asymptotes. Or you can substitute another point. So, down, and I'll just draw a curve. And notice the curve must move towards the asymptotes and down. If I substitute another point, you can see that I can go and substitute negative 3 into my equation. If I substitute negative 3, I'll get another point. So let's say we substitute negative 3 into my equation. So I'll get 2 over negative 3 plus 1 plus 3. So I'll get 2 over negative 2 plus 3. What do I end up with? Negative 1 plus 3, I get 2. So negative 3, and 2. That's what I mean by an additional point. I can do the same thing on this side. If I substitute positive 3 here, I can substitute it. So 2 divided by 3 plus 1 plus 3. Let's make it 2, makes it easier. Let's make it 1. So 2 divided by 2 is 1 plus 3 gives me 4. So this point here, 1 and 4. Just gives you an idea how your graph must go. So to find that point, I substituted 2 over 1 plus 1 plus 3. Okay, that's where I got that point from. This point, how did I get it? There. There's my additional point. Now, ladies and gentlemen, what I'm saying is the following. You saw me make a mistake and correct it. How did I correct it? Because I knew that if A is positive, our graph must lie in the first and in the third quadrant. Does it lie in the first and the third quadrant? Yes, it does. I have asymptotes that guide me. And the most important thing is, I went back to check where my error was made. Where was my error made? Remember, I illustrated something for you here, about x plus p, and I used this one. Instead of this one, it was written here, x minus 1. So I decided to go along with x plus 1, and you can see I followed through with it. And then the other mistake that I made is this plus 3. When it is transposed to the left-hand side, it becomes negative 3. I then collected everything, and you can see that my points lie in the correct quadrant. So we don't draw this graph by using the table. We draw the graph with asymptotes, x and y intercepts, and maybe 2 pairs of coordinates. You see that I'm putting 2 pairs of coordinates, namely that pair of coordinates and that pair of coordinates. What do the coordinates do? They just give me another point that I have to be able to draw my graph correctly. That's the only thing that they do. All this graph does, it moves towards the asymptotes and it gives a curve. It mustn't give a block, it must give a curve. And that's it. There is my vertical and horizontal shift. So there is my graph for you drawn completely. So there's how to draw the hyperbola, and where we look to be able to draw it. So I'd like you to write it down so that if you ever get stuck, you know how and where to do it. Now, please, it's not something difficult. The only thing that is new for you is the asymptotes. What makes it for me, I suppose, asymptotes, I left the P out here. What makes it, I suppose, difficult for me or hard for me is I'm working on a very big board. But that's not my excuse. Please write it down. Then we can do another one for you to see, to work together, so that we can see if we can help one another. Okay? And we'll talk it through so that we're all on the same page and we understand where we are going. So I've done it with you, I've done it for you, with all the stuff that's necessary, so that when you draw a hyperbola, and in most cases in grade 11, we can guarantee that you're going to get a hyperbola of some sort to draw. It's really easy marks in the exam for you to attain, and you get a good grade for asymptote. And we like to have the shifted graph in for you in grade 11 already. So to see the vertical shift, this one is a vertical and horizontal shift, but the quadrants are just, it still remains first and fourth, and asymptotes actually guide you. Okay. I want to talk about symmetry as well, so that you understand symmetry. Now, can you just write it down first? I am going to do another example. It's very important that we actually do another example of this one. Okay. Before we get to symmetry, because symmetry is another concept we have. Symmetry. Okay. Can we take this one off? Let's do it. Okay. Let's do a negative one. What happens if A is negative? Okay, let's do another one. Y is equal to Y, notice. Let's give him a nice name. Fx is equal to 1 over, and let's make it, 1 over x minus 4 plus 2. Minus 1. Let's make it like that. Let's do that. So, first things first. What do I need first of all to find? I need to find my asymptotes. So, question is, draw the graph. Draw the graph. Draw the graph. So, my solution, f of x is equal to, so I need first of all to find my asymptote on the x-axis. Oh, this one is also dry. I need a blue one. I'll just get another pen. This one. I need to find this one, and this one will be on the, it is my vertical asymptote. This one is my horizontal asymptote. Okay, so how do I find it? Well, this becomes x plus 4 equal to 0, x equal to minus 4. This one, including the sign, y is equal to 2, positive 2. Okay, so as it is. So let's draw it on our graph. Okay. Right, ladies and gentlemen, x-axis, y-axis. Put our points on meanwhile. 1, 2, 3, 4. Yes? What's wrong? Yes? One, 2, 3, 4, 5, 6, 7, minus, 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 minus. to understand that. 1, 2, 3, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay. I said that my asymptote, my vertical one is at x equal to minus 4. X equal to minus 4, I draw a dotted line. So the graph is going to move towards this line, but it won't touch it. My horizontal asymptote is at y equal to positive 2. So I draw in my horizontal asymptote, there it is, y equal to positive 2. Next step. What do I need to find? I need to find my x-intercepts. One only, my x-intercept, I set y equal to 0. So 0, another name for y is fx. So this is actually y. Remember, fx is the name of a graph. It's called f to distinguish it from other graphs. So, and in x, in other words, you will find the variable on the right hand side. So 0 is equal to minus 1 over x plus 4 plus 2. Notice that this one is negative, this term is negative, so I'll take it to the left hand side. So 1 over x plus 4 is equal to 2 over 1. Any whole number can be written as a fraction. Again, I'm going to cross multiply. So 1 from the denominator will multiply with 1 in the numerator, multiplied by 2, multiplied by x plus 4. So we remain here with 1 is equal to 2 multiplied by x is 2x, 2 multiplied by 4 is plus x. So 1 minus 8 is equal to 2x. Divide both sides then by, I get negative 7, and I'm going to divide both sides by 2. So x is going to be equal to negative 7 over 2. Again, as I did earlier, let's make sure that we are in the right quadrants. Okay, so this is going to give you negative 7, 8, and 0. Okay, let's see, I didn't make any mistakes now. Negative, take it over to the positive, cross multiply, get 1, 2x, 8, minus 7, divide by 2, I get negative 7 over 2. Okay, now for the y-intercept. Now y-intercept, what do? I set x equal to 0. So I set x equal to 0, so y is going to be equal to negative 1 over 0 plus 4 plus 2. So y is going to be equal to negative a quarter. Again, notice the denominator does not become 0. No plus anything is the anything plus 2. If you add the 2 together, you are going to get 2 gives me 8 quarters, so I'll have 7 over 4. 7 over 4. Written as coordinate pairs, x, y is equal to 0. Y-intercept is always as 0 as the x-intercept. I get 7 over 4. Then I also said, just for the sake of making sure that our points are drawn in the correct quadrant, let's take 2 more points so that we can actually draw in our correct quadrant. So let's take a point like x equal to minus 4. Let's say x equal to minus 4. If I substitute it, then it becomes minus 1. I'm going to put it on top here. If x is equal to minus 4, right, what happens? Then y will be equal to minus 1 over minus 4 plus, no, can't use minus 4, oh gosh. Minus 5, let's make it minus 5. X is equal to minus 5. Because I'm going to get 0 if I use minus 5. Minus 4. Minus 5. So let's use minus 5 plus 4 plus 2. I wouldn't like to use those numbers. No, that's fine. So y will be equal to minus 1 divided by minus 1 plus 2, and you can see that I'm going to end up with 1 plus 2, which is 3. So x is minus 5, y is 3. Let's use another point on this side. Let's say we're going to use x equal to, what number can we use? X is 0. Let's use a point like x is equal to 7, 5. If x is 0, if x is 0, I've already got, let's make it 5 for that matter. Or 4. If x be equal to 4, positive 4, then y must be equal to negative 1 over 4 plus 4 plus 2. Y will be equal to negative 1 over 8 plus 2, and y will now be equal to 7 over 8. Do I have something like that already? No, that's it, I don't have. So coordinate pair, x, y is equal to positive 4 and 7, 8. So there's my 2 points just to help me along. So now let's plot our points. Let's see if we really are coming into the second and the fourth quadrant. So my x-intercept, where is he? Minus 7 eighths and 0. So it's almost 1. That I must be almost 1. Minus 7 eighths and 0. So it's almost 1. Minus 7 eighths. Minus 7 eighths and 0. Where's my y-intercept? My y-intercept is just past, it's almost at 2. So that's 0 and 7 over 4. Right. Next thing that I want to do is I want to plot 4 and 7 over 8. Positive 4 and 7 over 8. Really? Positive 7 over 8 is going to be up here. That's not right. That's not right. Okay, look at the other side. Let's look at the other point. Like in minus 5 over 3. Minus 5 over minus 5 and 3. Minus 5 and we'll go to 3. So minus 5, we'll go to 3. So actually what I want, beautifully drawn. That point works for me. There it goes. This point here works for me as well. There it goes. All that I needed to do, ladies and gentlemen, draw and make sure that I'm in the correct quadrant. This point is 7 eighths. 4 and 7 eighths is somewhere over here, close by. There is 4 and 7 eighths. Notice it's going towards 2, but it doesn't eventually touch 2. And there we have our graph, just naming. You must just move closer. Remember the spacing of my graph that is perhaps doing this, that is not moving closer. Let me just make the line straighter. More straight. Okay. Okay. My graph must move towards it. So there, ladies and gentlemen, I've now plotted you a graph. Is it negative? Yes. Your x-intercept and y-intercept are both in your fourth quadrant. The quarters come in with your asymptotes. And there's your second quadrant graph. I even have a point for the second quadrant graph. There it is. Notice it's a curve, it moves towards, and there we have it. What do you think now, ladies and gentlemen? Do you think it's attainable? Do you think we can manage? This is how you draw a hyperbola. I see it's going to be break in a few minutes' time. So I think we should stop there. Your break is from 11 o'clock to 11:25. We'll carry on in the next period. Thank you so much. For 25 past. I'm back. Are we all ready? Okay. I'm ready to start. Okay, let's get started. So I want you to look at your summary sheet of functions, and I have a problem for you there. So I would like you to do it. I will write the sum on the page, on the board quickly, and so that you, if you don't have a booklet here, or where I'm working from, at least you can do one on your own, and we can just stop with that one. After this one, we'll do the last kind of graph, and then we'll do some mixed examples to show you. Now, in your notes pack, you have a summary of functions, and there is a problem in the second column, and it goes like this: given hx is equal to 1 over x plus 4 minus 2. That's the equation. Then it says 1.1. Determine the equation. Determine the equation of the asymptotes. Of h. 1.2. Determine the coordinates of the intercepts of the x and y axis. 1.3 for you to draw the graph. Both arms. Okay? So there you've got a problem quickly. I would like you to draw it for me, and we'll take it further from there. Don't worry, this is the last thing that I need to talk about with the hyperbola. It's symmetry. So there you go, ladies and gentlemen. That's for you to do quickly. So I would like us to answer that question. I'm going to give you 5 minutes, and then we'll take it from there. Just 5 minutes. Remember, you don't have to draw perfect graph. This is one of those graphs that you draw most freehand. So let's see what you get. Just 5 minutes. Are we done? Okay, let's go, ladies and gentlemen. Let's see what's happening here. Alright, I've asked you to determine the equation of the asymptotes of H. So let's see. Where do I look? At the bottom, or in my denominator, I'll find the first one. So determine the equation of the asymptotes, the first one. X plus 4 is equal to 0. Sorry, this thing is not working nicely. X plus 4 is equal to 0. Not that one either. This one is x plus 4 is equal to 0. It's also going to go soon. Let's just stick to the blank. X plus 4 is equal to 0. So therefore, x equal to minus 4 is my vertical asymptote. The next one, the add-on is my horizontal asymptote, so y equal to minus 2. Please, ladies and gentlemen, notice that asked me for an equation, so you can't write minus 4 down and minus 2 down. It's going to be in the correct format, so x equal to minus 4, y equal to minus 2. So those are your marks for it. Okay, so normally what happens is we will do this for the learners and that. It's normally worth 3 marks in the exam, or 2 or 3 marks only. Determine the coordinates of the intercepts of the x and the y axis. So you go ahead and find the x and the y intercept. So let's see what is the x and the y intercept. So for my x intercept, what do? I'm not rubbing off that sign because I need to do symmetry with you as well. X intercepts, set y equal to 0. So set y equal to 0. So 0 is equal to 1 over x plus 4. Minus 2. My add-on is negative, so I'm taking it to the other side, we're transposing it. So positive 2 over 1 is equal to 1 over x plus 4. My denominator on the right hand side multiplies by the numerator on the left hand side. 2 multiplied by x plus 4 is equal to the denominator on the left multiplied by the numerator on the right. Cross multiply, that is what we do. Okay? So now I get 2x plus 8 is equal to 1. So 2x is equal to 1 minus 8. And lo and behold, 2x is equal to minus 7. I divide by 2. X is equal to minus 7 over 2. Is that correct? If I made any mistakes, let's check. Minus 2 goes over positive. Cross multiply. Positive 2x, positive 8, positive 1, cross transpose. Okay, so that is my x-intercept. So now I know what my x-intercept is. My x-intercept is at minus 7 over 2 and 0. Okay, what are we doing when we want the y-intercept? For the y-intercept, what are we going to say? We are going to set x equal to 0. So I set x equal to 0 in my equation. So, y is going to be equal to 1 over 0 plus 4 minus 2. Anything added to 0 is the anything, so I get a quarter minus 2. Well, either your calculator or you can add your fractions with the LCM. So, how many quarters are there in 2? There are 8 quarters in 2, so I am taking away 1. So I'll get negative 7 over 8. I lied. There are 8 quarters. Yes, that's right. Negative 7 over 8 quarters. Oh, quarters, not 8. Negative 7 over 4. Yeah, quarters. So there are 8 quarters. And I'm taking away, so that's my y-intercept. Written as coordinate pair 0 and negative 7 over 4. Okay, last but not least, I've asked you to draw the graph. Now, I'm going to draw the graph at the bottom because I need the space. So let me just take out all the wording. So you've got your x, your asymptotes. We got our x-intercepts, minus 7 over 2 and 0, x-intercept, my y-intercept, and now I'm going to draw my graph. Okay, so, now can I take off this? May I take it off? Okay, I'm going to take off the x-intercept and the y-intercept. Because you would have worked it out yourself. So, there we go. Let's plot this graph. And then we're going to go on to the next graph, and then we're going to do a mixed problem. Okay, here we go. So we draw our axes. And the very first thing that I ask you to draw for me, name your axes. Don't forget, you must always name your axes. And I'm going to draw my asymptotes in. First things first, my first asymptote. It's minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5. Now ladies and gentlemen, usually we give you paper to draw on, so you don't have to worry about how accurate your graph is. We give you paper to draw on so that you can practice on it. So practice, if it's skew, it's fine, we'll help you out there. What's important around these graphs, ladies and gentlemen, is to understand what we are doing. Notice that A is positive. Where am I expecting my graph to be drawn? I'm expecting my graph to be drawn in the first and the third quadrant after my asymptotes have been drawn in. So my first asymptote is x equal to minus 4. So this is a vertical asymptote, and because x equal to, it must cut the x-axis. So let's plot it in. I just want to do it in another color. Yes?
Isn't the x-intercept equals negative
2? No. X equal to negative 4. Because your x-axis intercept is found below the, or in the denominator rather, of your equation. Your y is the add-on.
The x intercept cannot be equal to negative 4 because in the formula, the plus 4 shows the asymptote, the vertical asymptote. Therefore, x intercept cannot be negative 4.
Yeah, that's your vertical asymptote, it's negative 4. So you're saying this can't be negative 4. X equal to negative 4.
If your x-intercept is negative 7 over 2, right? But then we recalculate our x-intercept and it is negative 2.
Did I make a mistake there?
Yes, I think.
Okay, let me redo that then. Thank you. Okay, let's see. Thank you. Thanks for noting that. Let's just check it. It's my x-intercept. X-intercept, set y equal to 0. Okay, so 0 is equal to 1 over x plus 4 minus 2. So I take negative 2 over, it becomes positive 2 is equal to 1 over x plus 4. Right. So I cross multiply. So I cross it, so it's 2 multiplied by x plus 4 is equal to 1. So this is 2x. That is 8 over 1 plus 1. So 2x is equal to 1 minus 8. So 2x is equal to negative 7. Divide by 2. So x is equal to negative 7 over 2. So that's my x-intercept.
Thank you, guys.
Okay? Our y-intercept. I said x equal to 0. Right? So, y is equal to 1 over 0 plus 4 minus 2. Anything plus 0 is the anything, so y is equal to a quarter minus 2. There are 8 quarters in 2. I'm going to take away 1. So this gives me negative 7 over 4. So my y-intercept is at 0 and negative 7 over 4. Okay? That's where I get let's plot my graph. Three, 4, 5. Minus 1, minus 2, minus 3, minus 4, minus 5. Okay. Maybe I should just move my graph a little bit because I have an asymptote on the side. Okay. Let me just shift the graph a little bit that way. One, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. I'm just drawing the graph larger on the other side because I need to accommodate an asymptote on the side. 1, 2, 3, 4, 5. Okay, y-axis, x-axis. Now, let's draw an asymptote. Where is he? At x equal to minus 4. So, this is my vertical asymptote. So x equal to minus 4. I'm drawing it specifically in a color so that it doesn't show up anywhere. And the colors are my two work. Okay, he's doing it the job now. Okay, here he goes. This is the line x equal to minus 4. Okay, now we go to the horizontal asymptote. Where is he? Y equal to minus 2. There we go, that's the horizontal asymptote, y equal to minus 2. Now what are we expecting, ladies and gentlemen? I'm expecting, because my A is positive, so I'm expecting my graph to be drawn in the first and the third quadrant. Now, let's see. Remember, we always have our x-intercept, our y-intercept, and then we'll put 2 more points to draw. So my x-intercept is at minus 7 over 2, and 7 over 2 is about 3.5. So minus 3.5. So minus 3.5, comma 5, and 0. Here it is. My y-intercept is at minus 1 3/4. Minus 1 3/4, almost 2. So this is minus 1,75 and 0. So, those 2 points give me an idea. It can't be around that way, it's got to be around this way. Okay? Close to my asymptotes doesn't touch, close to my asymptote doesn't touch. I can simply go and draw my other side, my other arm on the other side. I don't even have to measure it. I've got that particular point. But let's be difficult and go and find another point maybe on the side. So let's put in minus 5. So, if x is equal to minus 5, then I get y will be equal to 1 over minus 5 plus 4 minus 2. So y will be equal to minus 1 minus 2. So y will be equal to minus 3. So when x is equal to minus 5, y will be equal to minus 3. So minus 5 and 3. So this must be a little closer according to the sketch. Must be drawn a little closer. Can you see this point is there, is in that quadrant there, minus 5 and minus 3. That's what I'm trying to say. It's correct. There's the coordinate there. Minus 5 and minus 3 coming from there. Minus 5 and minus 3. Now to put another point here, let's say. Let's say I decide that I would like to put in 4 and negative 2, no. 1x and negative 2, 1x and negative 2 will give me. If I decide to put 4 in here, let's say x equal to 4, I will get y equal to 1 over 4 plus 4 minus 2. So y will be equal to 1/8 minus 2. There are 8 8s in 2, so I'll have minus 7, no, yeah, minus, no, I'm lying. 8 8s, yes? No. 16 8s, sorry. So there's 15 8s left. So it's almost 2, and you can see there, it's almost minus 2. Does it make that better? So this becomes minus 15 over 8, because there are 16 8s in 2. So it will be right here. If I use 4, it's going close to the 2, but it's not going to touch it. So this is 0.4 and minus 16 over 8. So ladies and gentlemen, there's my graph drawn for you. Notice I can just draw the other arm into the third quadrant. I found points in the third quadrant to show you that it will be in the third quadrant. There's a graph in your first quadrant. So there's my graph. And as you can see, ladies and gentlemen, once you practice it a few times, you will actually get the hang of it and realize that this is the graph where you have to take note of asymptotes. So this is the important part, that you recognize your vertical and horizontal asymptotes. The last thing that we must remember in this graph is, you also have a line of symmetry. Now, what is a line of symmetry? But I show you how to calculate a line of symmetry. Okay. A line of symmetry, this is something that you need to write down. Line of symmetry. Now in grade 10, your graph looked like this. In grade 10, your graphs look like that. And your teacher might have asked you, can I fold these two graphs over? Can I fold these two graphs over? And often we would ask ourselves, what do you want, sir? What do you mean by fold? These graphs form a mirror image of each other. Right? Now how do they form a mirror image? They must fold over a line. So when we look at your parabola, remember your parabola? What is your fold line for parabola? Along which line do we fold the parabola? Remember the axis of symmetry is your fold line. So the distance on this side is the same as the distance on that side. That is the fold line. So we call the line that divides or that your parabola can fold on is your axis of symmetry. So the line of symmetry for this graph, this one doesn't have a mirror image on that in that quadrant. This graph has a mirror image in which quadrant? In the fourth quadrant. So the line that we use for symmetry is this line. And this line is got an equation, and the line of that equation is y equal to x. So this graph will form a mirror image or will fold over this graph and y equal to positive x. That is what the line of symmetry is. So this graph is symmetrical along the line y equal to x. This graph, again, is symmetrical around the line because it's in the negative direction. It will be symmetrical around the line y equal to minus x. That is the most important thing. Yes, ladies and gentlemen, we can cut the graph in half and then we can do other things, but the most important thing is it's either symmetrical around the line y equal to minus x, or it is symmetrical around the line y equal to positive x. In other words, the fold line, so into which quadrant will it fold? If it folds into the first and the third quadrant, it folds along the line y equal to minus x. If it folds from the second to the fourth quadrant, y equal to x is the line. Now very often, ladies and gentlemen, you will find this question in the paper. Find the equation of the axis of symmetry of the graph. Then students look and they say, goodness gracious me, we can see it in a basic graph, but how on earth do we see it when we have a graph like this? Now what has happened in the case of this graph? What has happened in the case of this graph? Very easy, ladies and gentlemen. What happens when you have your graph and a horizontal asymptote and a vertical asymptote is the graph is simply shifted. So this graph is no longer in the first quadrant, it's no longer, we can't see it in the first quadrant, it is moved. So not only has it moved horizontally, it's also moved vertically down. So guess what? The 0, 0 that we have, the 0, 0 that we have, here's the 0, 0, has now shifted. And you see, you now have your axis of your two asymptotes. They form your new point around which your graphs are going to form a line of symmetry. And you can find that equation. So my asymptotes equation was firstly x equal to minus 4 and y equal to 2. Now I can find that equation by the following way. First thing that I do is, I need to find the gradient of this line. Now how do I know the gradient of this line? I know the gradient of this line by comparing it to my basic graph. What is the gradient of this line? If it goes in the negative direction, in other words, your graph is in the first and the third quadrant, then the gradient of the line is minus 1. I take this y minus 1 and I take the second coordinates and I find the equation of the line. That is how I find the line of symmetry. Everybody with me? If, however, my graph is in the second and the fourth quadrant, which axis of symmetry will it follow? Well, the axis of symmetry is symmetrical, if I remember correctly, it follows the one which has a positive 1 as a gradient. So the gradient in this case, m is equal to positive 1. What is my points for my asymptotes? What were they? It was minus 4 and 2. All that you now need is the equation of the line, and you can find the axis of symmetry. That is how we go about it. Shall I say it again for those of us that don't understand? Okay. Your fold line, or some of your graphs, fold along a particular line. Remember? I asked you, how does your left eye fall on your right eye? I made a big thing about that. I said that there is a fold line. So your left eye falls on, left eye falls onto your right eye, your left ear falls on your right ear. With the parabola you saw lines of symmetry. Because if you draw the parabola, let's see, there is the parabola going. And I said to you, if you take x1 and x2 and you add them together, you are going to find the axis of symmetry. Right. In other words, this point here is the midpoint of those two roots. Now the very same concept works with our graphs over here. So these graphs, in other words, this graph over here is exactly the same over there. The distance on this side is exactly the same over here. So if I know this point over here, let's say it's minus 2, the x value is minus 2 over there on the side, then I know the positive here value is 4, minus 4 here, and that's minus 2 over there. I know what that point is. How do I know? This one will be 4 plus 2, which is 6. If I add 6 to the 2, I will be able to find that one. Because it's 6 units across this way, 6 units across that way, and I can find the 2 points. Let's check it out. If I take 6 minus 4, so now I add it correctly. It's 4 units plus 2 units. That's not 6. It's we just see it's 4 plus 2 is 6. It must give me 6, so I must say it's not 6. If you just think quickly, it can't be 6, then that must be 4. I'm just thinking 4 plus 2. Let's just see that if I work it out quickly. So it's x1 plus minus 4 over 2 must be equal to positive 2. So that means x1 is equal to 4 minus 4 plus 4. It must be 8. It's 8. Okay, let's see if it's 8. So it's going to be 8. Oh yes, that's right. It will be 8. We must add 6 units. So 6 plus 2 does equal 8. It's correct. It is 6 units because the distance between on this side is 6 units. I must add 6 units to the 2, and that's how I get my 8 over there. Let's talk about line of symmetry on grade 10. You have a parabola, hyperbola in the first quadrant and the third quadrant. Now, this graph folds into this quadrant around a particular line. And the line is the line here, y equal to x. So in other words, this graph falls onto this graph if I fold it along that line. Y equal to x. The point that it crosses is the point 0, 0. X equal to 0, y equal to 0. The graph that's in the first and in the third quadrant also follows around the, I've just done that one, sorry. The graph in the second and the fourth quadrant also folds around the line. 0, 0, goes through 0, 0, but it folds around the line. This is minus, this is plus. Because it's going into the negative direction, this one goes into the positive direction. Why do we need it? Because when we want to find the axis of symmetry or the symmetrical line, for these graphs, all that we need is we need the gradient and we need your points where your asymptotes cross. Okay, so in other words, where does my asymptotes cross? In this case, my asymptotes cross over there, and I notice that my graph is in the first and in the third quadrant. So my graph is going into the negative direction, so the gradient of this graph must be -1. Where does it come from? Remember, this graph is now shifted both horizontally and vertically it's shifted. It has a negative gradient, okay, like this one. I'm taking it from here, and I use the pair of coordinates coming from my asymptotes, which is -4 and 2. I use the equation of a line, and I can find its axis of symmetry that this graph folds along. I do the same thing if the graph lies in the second and the fourth quadrant. What do? I must find out, I must just have a look, draw the line in for yourself. It's moving in the positive direction, therefore the gradient of this line must be +1. I just have a look at where my asymptotes meet, and I write down the asymptotes as my coordinate pair, so it's -4 and 2, and the equation of a line, and that is how I find the axis of symmetry for a hyperbola. So that is how I do a hyperbola. There's just one more thing that I must do with you. What happens if we get the graph in another form? I'm not going to spend lots of time. You can negotiate with your teacher. They can add and subtract and do this graph with you. Okay. Sometimes by fluke, the teachers give you this one. And they say to you, draw this graph, or rewrite this graph in the correct form. And yes, ladies and gentlemen, it is also a hyperbola. There are two ways to do it. There's the fast way and there's the slow way. The fast way is by adding and subtracting in the numerator, and the slow way is by using long division. Now the fast way is by inspection, and the slow way is by using long division. So I'm going to put the long division part on for you. Your teacher can take you through this once. I'm not going to do this very much. I'm just going to show you how we go about it, both ways, so that you can see how it's done, and then your teacher can go with you through more of it. But it comes sometimes into an exam and the learners are stuck with it. Okay, if I use long division for this thing, then it means the following. All you must do, ladies and gentlemen, you must just follow. When you were in primary school, the teacher used to say 20 divided by 5, right? Or make it 120 divided by 5. Some of us used to do little houses. Then we take the top number, we put it at the bottom, and we put the 5 outside. So that's how we divide it. And then we say 5 goes into 12. How many times? Twice. 2 multiplied by 5 is 10. What did we do with the 10? We subtracted the 10. We ended up with 2 and we brought the 0 down. Okay, let's make it not 120, but let's make it 121. There's a reason why I want it. So now we bring the 21 down. 5 divided into 21 how many times? 4 times. 4 multiplied by 5, then be 20. I subtract it and I end up with 1. This one is the remainder. So it must ask me, what is 121 divided by 5? Then my answer would be 24 plus 1 over 5. There's still 1/5 left. 1 over 5. First, digest that. This is how you did it in primary school. This is how you divide subtract. Now this long division that I'm talking about is exactly the same. We're going to do exactly the same. We're going to divide, but you're going to use some number. It's going to do it. The one at the bottom goes to the side. Okay. Now what did we do? Here we said 5 goes into top. Here we're going to say x, just x, goes into x. How many times? X divides into x. So let me write it. X divides into x. Just for those of us that are stuck. In other words, x divides over x and I end up with 1. So then what do I do? So then you write the answer on top. You multiply by the divisor. So 1 multiplied by x is x, 1 multiplied by negative 1 is negative 1. What must we do now? You subtract. What happens when you subtract? Well, the sign changes. So it used to be 2 multiplied by 5 is 10, positive. But the signs now change. So he's minus, he's plus. Like you did it in grade 9. A positive x and a negative x cancels. Positive 1 and positive 1 gives me 2. So, what is this now again? This is the remainder. So, just like we did in primary school, what is my solution? So, x plus 1 divided by x minus 1 is simply 1 plus my remainder over whatever I divided by. If I rewrite it in the correct form, 2 over x minus 1 plus 1. And there I have my parabola written in the correct form. In other words, I can see my asymptotes like I need it. So ladies and gentlemen, this is rewriting. So this is an equation of an asymptote. Of my parabola. But it's not in the correct form. You need to write it in the correct form. That's using long division. Okay? I put this sum over here, not because anybody's stupid, not because anybody's handicapped, but to show you that the methodology is exactly the same. I wrote it here so that you can see. The process is the same. When you divide 5 into 12, you get 2. 2 multiplied by 5 is 10. You subtract. 2. Bring down the 1. You subtract. The remainder. So it's 24 from the top. And 1 over 5. I use the number specifically so that you can see what you do there is the same process that you do over here. And that's often the difference between high school and private school. As I said to you, I'm not going to spend a lot of time. Your teacher can show you this in depth. If it ever comes up, you will know that you must be able to do it. The one thing that I must remind you about very often is some people like to do it by inspection. So what they do is, they say the following. In my denominator, I've got x minus 1. So my numerator has to change. So they write x minus 1 there, but they actually got x plus 1 there. So what must I add to x to make it this one here? So I've got the plus 1. So these two will cancel. Are you with me? But I've got the 1 there already. So I can't have 1 here, I need another 1. So these, in other words, this 2 will cancel. Are you with me? That's what they do. They've taken the denominator and they just added and subtracted the inverse. So they add and subtract the same number. So if I get y is equal to x plus 3 divided by x minus 4. Then all that they do is y is equal to x minus 4. plus 4 plus 3 over x minus 4. So what do they want? They want x minus 1. So, in other words, this whole sum becomes x minus 1 plus 2 over x minus 1. So they want the x minus 1s to be on its own. So this then becomes x minus 1 over x minus 1 plus 2 over x minus 1. Here becomes x minus 4 plus 7. The x minus 4 they want to isolate, and they simply do this. So this becomes x minus 4 over x minus 4 plus 7 over x minus 4. You can see it already. This will be 1 plus 7 over x minus 4. That's how they do it by section. And subtract the number in the denominator. So let's put and that's how you do it by inspection. So this is by inspection with those that are very quick on it. So a bit more difficult if you have a 2x here, it's a bit more difficult if you have a 2x there. So don't always think it's going to work out in this particular fashion. But that's by inspection. I don't want to spend too much time doing this. Your teacher can sit and practice this particular one with you. Okay, there's another graph we have to consider, ladies and gentlemen. So let's consider this graph. And that is your exponential graph. Now again, ladies and gentlemen, before I start this graph, your parabola has to consider a turning point. So your line graph only had x and y intercepts, but your parabola included a turning point. Your hyperbola had asymptotes and symmetry to consider. So now we're going to look at your exponential graph and its peculiar habits. So every graph has got something extra to it or something that you must always consider. Okay. By now already you know the domain and the range of a hyperbola. I don't have to show you that one. So let's consider the fourth graph, which happens to be the exponential graph. Okay, so let's look at the exponential graph. Well, it's normally in this form. Y is equal to a to the power of x. If I'm coming from grade 10. And you don't need to write this down because you've already done this. So, y is equal to 2 to the power of x. This is the one graph, ladies and gentlemen, that we don't use a x-intercept and a y-intercept for. It's the graph where we use a table so that we can be more accurate. So, let's see. If I draw this graph by my table, then I'm going to find the following. X and y. Again, I'm going to draw my column so that those who need it can see where I'm going. Okay, so if x is equal to minus 2, so y is equal to 2 to the power minus 2. Any whole number with a negative exponent can be written as a fraction with a positive exponent and I get a quarter. Next one, x is equal to minus 1. Any whole number with a negative exponent can be written as a fraction with a positive exponent. Okay. Y is equal to 2 to the exponent 0. Anything to the power 0 is 1. Okay. Y is equal to 2 to the power 1, so I get 2. Y is equal to 2 to the power 2, done more today, and I end up with 4. So that is my coordinate pairs for this particular graph. So I can go ahead and draw this graph, very basic. Y is equal to 2 to the power x, minus 1, minus 2, 1, 2, 1, 2, 3. Y-axis, x-axis. This is the most simple one of them of all of these that we have. So x is equal to minus 2, y is a quarter, so it's just about there. When x is equal to a half, minus 1, it's a half y-axis. X is equal to 0, y is 1. When x is equal to 1, y is 2. I needed 4 right on top. And when x is 2, y happens to be 4. So this graph gives me a run for money. This graph, as the saying says, it is exponential. Now again, ladies and gentlemen, this is my graph, y equal to 2 to the power x, and now let's check. If I put 3 here, what's going to happen? Let's say I put minus 3 on the side. What's going to happen? What if I substitute minus 3 in there, then y with 2 to the power minus 3, any whole number with a negative exponent can be written as a fraction with a positive exponent. So 2 to the power 3 gives me 8. So I'll get 1 over 8. So what is happening, ladies and gentlemen? The number is becoming smaller and smaller and smaller, and it really is not going to touch the line y equal to 0. So what's important around this graph is it's not touching this line. So it doesn't touch this line. So what kind of line is it? This will then be called an asymptote, because it doesn't touch that line. This line is then called an asymptote. That line is an asymptote. Right. This number over here, this is a unique number. It's a unique number. In other words, this is the only graph that will pass through your y-axis somewhere. Because it must pass through the y-axis. And it will have, in other words, it's got somewhere, it's got a 2 to the 0. Somewhere. So it's got a unique point, we call it. Okay. Important around this graph is that it's got a funny range. Okay, domain, you know already. If I look at the domain of this graph, what's the domain going to be? Well, you know already, domain always, the graph always picks up x values. You don't have a problem with picking up x values. Please, I'm still with grade 10, I'm not in grade 11 yet. The domain of this graph is always x, an element of the real numbers. In other words, the smallest x value is minus infinity, the largest x value is positive infinity. But the range is my problem. The range in this case, there are no values of x, of y at the bottom. Therefore, y, something about 0. It cannot be equal to 0 because the graph doesn't touch this this line y equal to 0. It cannot be, I cannot make this graph less than 0. I've got to make this graph, because it's not, there's nothing at the bottom, I've got to make this graph y larger than 0, because I have this as an asymptote. So only if it cuts it or touches it can I make it equal. It's got to be y larger than 0. Some people still write on here y an element of the reals and put the plus sign there. But the answer is actually y is just simply larger than 0. Now notice, I haven't been using symmetry, I haven't folded the graph over and those kind of things, but simply that is the important thing around an exponential graph. So an exponential graph, plain and simple, it will have a unique point in your grade 10, it has an asymptote, domain and range, there is no symmetry for this graph as it is over there, and we use a table to draw it and not x-intercept and y-intercept. Because of a lot of the confusion. Now the same things will happen to this graph like we did all the other graphs. So what are we going to explore? We're going to explore in grade 11 your vertical shift, and we're going to explore your horizontal shift. So let's look at the vertical shift. What happens if we have a vertical shift? So I'm going to do one that has a vertical shift so that we can see what happens. So I'm leaving the basic one, so we're going to put the vertical shift on, and then we're going to do horizontal shift, and then we put them all together. So that you can just see what it looks like. Okay, let's go. My equation, y is equal to 2 to the power x plus 1. Okay, so let's see. Y is equal to 2 to the power x plus 1. So if x is equal to let's take the minus 3 away from it for a moment. If x is equal to minus 2, so it goes 2 to the power minus 2, right? Plus 1. So that means 2 to the power minus 2 will give us a quarter, will give us 1 over 2 to the power 2 plus 1. So that is 1 and a quarter. 1 and a quarter. The next one, 2 to the power minus 1 plus 1. This will give us 1 over 2 plus 1, which will give us 1 and a half. If x is equal to 0, so 2 to the power 0 plus 1. Okay, I'll get 1 plus 1, which is 2. Next one, y is equal to 1. Y is equal to 1. So, x is equal to 1. 2 to the power 1 plus 1. That will give me 2 plus 1. So y is equal to 3. Next one. Y is equal to 2 to the power 2 plus 1. This will give me 5. This gives me 4 plus 1, sorry, 4 plus 1. That gives me 5. Okay? So there I've got all my working out for this particular graph. I could have put 3 in here, and I would simply have had y is equal to 2 to the power minus 3 plus 1, and I would have got an x plus 1, so it would be 1 and an 8. That's what I'm saying. Now we can go into y graph. So let's draw this graph to show you how it looks like. Let's draw y graph. Okay, so 1, 2, 3, 4, 5, let's go 6. Okay. Minus 1, minus 2, minus 3. 1, 2, 3. Minus 1, minus 2, minus 3. Okay. If x is minus 3, I've got 1 and an 8. Minus 3, I've got 1 and 8. So it's just a bit up beyond the word number 1. If I've got minus 2, I've got 1 and a quarter. That's a bit higher than that particular point. If I've got minus 1, I've got 1 and a half. Halfway. If I've got 0, I get 2. If I have 1, what happens now? I get 3 plus 1. 3. Goes to 3. If I get 2, I'm going to 5. Now, ladies and gentlemen, what is different to this one compared to the previous graph? What is different? What is different? Well, let's go back to the previous graph's numbers quickly. Previous graph's table, let's put it up here for you. Previous graph's table. When x was minus 3, it was an x. When x was minus 2, it was a quarter. When x was minus 1, it was a half. When x was 0, it was 1. When x was 1, it was 2. When it was 2, it was 4. What has happened now? This one here is y equal to 2 to the power x. At graph, there's this table. This one here, y equal to 2 to the power x plus 1. What's the difference between the two? If I just look at the tables, I can already see the difference. We also know from the previous graph, we spoke about the adding on of things. When I add on things, this gives me a horizontal asymptote. Am I telling the truth? Well, let's go to our table. Let's look at our table. If I look at the second table, every point that I have here is one more than what I had before. So, watch. One more. So in this case, ladies and gentlemen, my unique point is no more 0, 1, it now becomes 0, 2. But it still has a unique point passing through the y-axis. It has shifted vertically. How come it shifted vertically? Because I've got an add on. That's why it shifted vertically. And it's going through 0, 2 now. And this is my asymptote for my exponential graph. Let me put it there, y equal to 1. So what is the graph doing right now, ladies and gentlemen? If I'm looking at the domain and the range right now, my domain remains, because I'm always going to pick up x values, no problem. My domain remains. My domain remains x an element of the reals. Always picking up x element of the reals. But now y for the range changes. In other words, there's nothing beneath the line y equal to 1. Therefore my range is y must be larger than 1. Or y must be more than 1. And there we go. That is how you find your exponential graph. So that's the easier one of all of them. Okay? Can it have an axial symmetry? Can we draw another graph in? Yes. But in a nutshell, that's the important part of drawing your exponential graph. Okay. Let's just look at the horizontal shift. What will the horizontal shift look like? Okay. Let's look at the graph y equal to 2 to the power x minus 2. Let's do that one. Make it 2x to the power minus 2. Let's just have a look at what happens if I have a graph like that. Now let's not put x to the power minus 2. Let's make it minus 1 so that the numbers are not the same. Draw a table. Can I just take the range off and write it at the bottom here so that I can use it inside? Range. Y must be larger than 1. Domain stays the same. X is an element of the reals. Okay. So this is this graph. Okay? Okay, this is the line y equal to 1. Okay, so then I can take this bit off and I can use my border sign. Okay, let's draw my table again. X and Y, again I'm starting with minus 2, minus 1, 0, 1 and 2. Notice there are numbers around the x-axis, x equal to 0. I'm not taking lots of numbers, I'm just taking a sample of numbers because I just need to have an idea of what shape and where I must go more or less. Okay, so let's substitute minus 2. So y is equal to 2 to the power minus 2 minus 1. So y will be equal to 2 to the power minus 3. Any whole number with a negative exponent can be written as a fraction with a positive exponent. So I get an x. Next one. Y is equal to 2 to the power minus 1 minus 1. So y will be equal to 2 to the power minus 2. Any whole number with a negative exponent can be written as a fraction with a positive exponent. So what do I end up with? I end up with 1 over 2 to the power 2, which is a quarter. Next one. X is equal to 0. So y is equal to 2 to the power 0 minus 1. So y is going to be equal to 2 to the power minus 1. Any whole number with a negative exponent can be written as a fraction with a positive exponent. I end up with a half. Look at that. Next one. Y is equal to, now in this case x is 1. 2 to the power 1 minus 1. So y is equal to 2 to the power 0. Okay? Y is equal to anything to the power 0 is 1. Wow. Next one. I did minus 1 already. X is equal to 0. X is equal to 2. Y is now going to substitute 2. So x to the power is now going to be substituted with 2. 2 minus 1. So y will simply be equal to 2 to the power 1, which gives me 2. I'm going to plot my graph. Okay, let's see. Okay, the highest number I'm going to go to is 2, so let's just make it very big. Big. Okay, y-axis, x-axis. Now, let's plot. When x is minus 2, y is equal to an eighth. Half, quarter, eighth. So that's a half. Okay, so a quarter. So it's an eighth, quarter, and eighth. So when it's minus 2, it's going to be equal to 8. When it's minus 1, it's a quarter. When it's 0, it's a half. There. Not there. When it's going to be positive 1, it goes to 1. When it's 2, it goes all the way to 2. Right. So we've seen a horizontal asymptote. What has happened in this case? This is my, is this a vertical asymptote? Can we say it's a vertical asymptote? This is the effect of a shift. It gives me a flatter curve. Very important to note, I've got a much flatter curve. My unique point is half of what it was previously. I get a much flatter curve than originally. This is a much sharper curve. This is what happens. It's a much flatter curve. It's more, can you see it's not as steep as this one. It's much flatter than the other one. So that's basically what happens with these graphs. We don't get this one too often. This one more often. We can also get a graph like this. Y is equal to 3 times 2 to the power x. That kind of thing. But in general, ladies and gentlemen, that is how an exponential graph is drawn. Use your table and you plot the points. Now, it's not difficult to do. It's just certain things that you've got to keep your head about. Namely, the asymptote. There is definitely an asymptote. It's horizontal. And it is normally one of your axes, or it is the add-on that becomes the asymptote. That's why I showed you that first. Take note of the range. It's not equal to, it's larger than. Else is there, you draw this graph by using a little table, some points around it. Some of us are bright, we can just use 2 points and it works. But in general, a little table. Practice that's perfect, and that enables you to do this quicker than coming into the exam room and taking 10 minutes to draw this. Okay, now what we need to do is, we need to see whether we can actually do this by looking at a few questions. So, let's see. Let's answer one of the questions that they give us on an exponential graph. We just give you one of them. So, if you have something added on in the x, then you know that your curve is going to be much flatter. If you have a horizontal shift, or not a horizontal, a vertical shift, the graph moves up. Our horizontal asymptote. this one doesn't say whether it's going to cut your x-axis, it doesn't have that. This graph doesn't cut the x-axis, that's so important. Okay, so this is the graph, it doesn't cut the x-axis. Always important to remember. It doesn't cut the x-axis, but it does have x-intercepts. Okay. On your page of functions, there's a question that reads, the sketch shows the graph of fx equal to 3 to the power x minus p plus q. Okay? And then they give us some wording. So here they say y is equal to minus 1. The graph is drawn for us. Here it goes through 1. So something must have happened to this graph. Because normally it doesn't go through the x-axis. Normally it doesn't go through the x-axis, and this graph is going through the x-axis. So, let's see. They want first of all, determine values of P and Q. And secondly, what do they want? The coordinates of the y-intercept. You have a page, but just in case you don't have a page, I'm just writing the questions for you. The domain and the range. That's what they want, domain and range. And number 4, the new equation if graph shifted up by 1 unit. So there's my question. I need to be able to answer it. So they've given me an equation, and here is my graph. So you get only confused. Okay, so now I see. There's my graph. This is y-axis. They've given me a point on the x-axis. They've given me y equal to minus 1. So now I need to look at this graph and I need to evaluate what I can use and what I can't use. Okay, the first thing that I noticed, I'm moving towards this dotted line. So the dotted line is normally my add-on. So this is a asymptote. Okay, it's my add-on. Just give me a minute, please. Okay, that was just an emergency. So, y equal to minus 1 is an asymptote that I've got. I know that's my add-on. So I'm getting the question, they've given me the equation, there are unknowns in the equation. There's a P and there's a Q. So I know that the P is a flatter curve. So I know the Q. So now I go back to my equation. If x is equal to 3 to the power x minus p, sorry my x is so bit funny, plus add on, I put put in exactly as they gave it to me. So what is my add-on? My add-on happens to be, sorry, I just want to close this page. My add-on happens to be plus q, and in this case it is minus 1. That's the first thing that I do. The next thing that I notice is I've got a pair of coordinates. So this coordinate pair 1, or this point 1, becomes the coordinate pair 1, 0. Right. So now I'm going to substitute 1, 0 into my equation. So I put in my asymptote. So substitute my asymptote. That's what I did. Substitute asymptote. Now I'm going to substitute my coordinate pair. Coordinate pair. Okay, so for those of us that are stuck, that's what I'm going to do. Another name for fx is y, so there we go. Okay, so that's my equation. Now what happens? This is x, y. So y happens to be 0. 3 to the power. The value of x happens to be 1. Minus p. Minus 1. So, this part is negative, so I'll take it across the other side. 1 is equal to 3 to the power 1 minus p. Now, when do we get 1 now again? With exponents, any number to the exponent 0 is 1. So the base of the side is 3, I can make that base 3 to the power 0. And hence I can solve. Okay, again for those who understand, I've got a base 3 here, and I've got the number 1. So now I remember, any number to the exponent 0 is 1. So I can rewrite this number, 1, and give it the same base as the other side. 3 to the power 0 is 1. And now I can solve for p. So 0 is equal to 1 minus p. So p is equal to 1. Now I've got my whole equation, ladies and gentlemen, and my equation is simply y equal to fx is equal to 3 to the power x minus 1 minus 1. So my values of a, I've got p, and I can actually say to them that q is equal to minus 1. They are my 2 values. Okay, that was number 1. Okay, number 2. What is the coordinates of my y-intercept? So my y-intercept, I set x equal to 0. So let's see. Y-intercept, they're giving me an instruction, so let's find y-intercept, set x equal to 0. So, y is equal to 3 to the power 0 minus 1 minus 1. Anything added or subtracted stays with anything minus 1. So this is going to give me a third minus 1. There are 3/3 in 1. So I'm going to remain here with negative 2/3. So I want to set, and it asks me for the coordinate, so I actually have to give them a coordinate pair. So 0 and negative 2/3. Right. The third question, so this is number 2. The third question they asked me to find. Ask me for the domain and the range. Now the domain, ladies and gentlemen, is x an element. Right. Question, how do I find the domain? It's read from left to right. So, does the graph become x values? Well, I can draw this all the time. Does the graph become x values? In other words, there's no way there's a break in the graph. It's not broken anywhere. Indefinite start, indefinite end. So x is an element of the reals. Or if you prefer, x is an element from minus infinity under positive infinity. Right. What about the range? Right. When we're dealing with an exponential graph, find your asymptote. So I give my asymptote. Where's my asymptote? At y equal to minus 1. In the case of an exponential graph, there will be nothing beneath the asymptote. So, my graph starts at the asymptote. So for the range, y and the asymptote. Now, it can't be equal to the asymptote because the graph does not touch the asymptote. So it will always be larger than the asymptote. Here's my range. Number 4. They say, find the equation if the graph is shifted up by 1 unit. Now I want the graph to shift up by 1 unit now. How on earth am I going to do that? Well, let's see. This graph is shifted up by 1 unit. Is it possible for me just to go and add on? Let's see. F of x is equal to 3 to the power x minus 1 minus 1. So they want a new graph. So let's give him a new equation. G of x is going to be 3 to the power x minus 1 minus 1 plus 1. Let's see if I'm going to have a change. So in other words, I'm just going to have 3 to the power x minus 1. Right, let's see if I'm going to have a change in my graph. Do I have an asymptote now? I mean an asymptote that's the same as that one? No. My graph is now going to shift upwards by 1 unit, and it's going to have the x-axis as its asymptote, in other words. So the x-axis becomes this new graph's asymptote. So let's see where its points are going to be. Have I shifted? And did I do the right procedure? I'm going to draw a table to help me to find the points. X, y, minus 2, minus 1, 0, 1, and 2. Oh, we can substitute in here. X is minus 2. I'll get 3 to the power minus 3. So it becomes 1 over 27. If x is equal to minus 1, this becomes 3 to the power minus 2, 1 over 9. If x is 0, this becomes 3 to the minus 1, which gives me 3 to the minus 1 gives me a third. If x is equal to 0, I get 1. 3 to the 0 is 1. If I get 2, 3 to the power 1 gives me 3. I just want to see whether my shift is happening. If x is 2, what do I have? Minus 2. I just want to see if it's going to shift. Minus 1, minus 2, and that's 1, and that's 2. So, let's take a cold ink so that we can see whether we're going to get a shifted graph. We should get a shifted graph, and it should be going upward. I'm just going to put in some points, so let's just see. If x is minus 2, y is going to be 1 over 27. Goodness gracious me. 1 over 27 is like left, right almost on the line. If x is minus 1, gee whiz, that's a nice, very small, very close. If x is going to be 0, it's a third. My goodness. Oh yes, this is a very flat graph. So this is going to be 0 and a third. Then what do we have? If x is 1, y is 1. X is 1, y is 1. If x is 2, y is 3. 2 and 3 somewhere. So there's my graph going at the end of the day. There it is. Ladies and gentlemen, has my graph shifted up by 1 unit? Has my graph shifted up by 1 unit? Well, my y-intercept was at minus 2 over 3. You remember? Our y-intercept was at minus 2 over 3. My y-intercept now is at the third. If I add the two numbers together, 1/3 plus 2/3, this gives me 3/3, which is 1. The distance between the two y-intercepts is 1 unit. And therefore my graph has moved up by 1 unit. So I've gone ahead and I've worked it out for you. So what does it mean? I've added, I just add on the 1 and I simplify. And there we go. I've drawn in the graph so that you can see that the graph really moves up by 1 unit. And there we go. So that's my exponential graph. It's a problem worked out and we have solved for it. Now, let's go further and try some more problems. What did I do with my page now? Here we go. So we've now done that particular graph. I would like us to look at number 14 quickly. No, stop number 14. Let's look at number 11.1. No, let's go to number 14. What is no problem with number 14? Now, ladies and gentlemen, usually you will get your graphs together. So, it's knowing where to look when I'm solving my graph. They are not difficult equations or difficult problems, but what happens is sometimes we become confused and we're not sure of what we should be doing. So, what I'm trying to do is to show you how the graphs are presented so that you have a good idea of what is expected of you in the exam, the kind of things that you will have in the exam. Okay? Don't throw away your grade 11 books. You're going to need the same work in grade 12. Now, in the problem that we have right now, I said number 14, and number 14's problem has a graph that looks like this. I'm going to draw it for you. Okay? It's got an asymptote, and it says 3 over here, it says B over there, C over the side. This is my y-axis, and my line G goes through this side, it goes through C. If you have the notes, you understand what I'm doing, you know what we are about to do. Our parabola's name is F. Okay. Now, the sketch shows the graph of F and G. G of X is the equation X over 2 minus 7 over 2. The two graphs intersect at E and at C. There is an E, and that one is at intersect at E and at C. The axis of symmetry of F is X equal to 3. So this is the axis of symmetry, and X is equal to 3. Right. B, C, and E is the intercepts for the axes. So at E, I notice that's the intercept for the y-axis, B and C are my roots or x-intercepts. Now, show that the coordinates of C are 7 and 0. Now the first thing I know, ladies and gentlemen, is I have a look at this. Because that's the only equation that they've given me. How can that equation help me? What can help me to find C? But I'm looking at the form of the equation. It's unfamiliar to me. I am not used to writing it that way. So the best thing that you can do for yourself is to write it the way you know it. Namely, as a half of x. In other words, mx minus c. The turning point, your y value, or your c. So there is written in the way that you recognize your line. Namely, y is equal to mx plus or minus c. So now you can compare it. Okay, always be careful. It's not a quadratic. How do I know? There's no square there. So, what can I do immediately? This minus 7 over 2. This is the line graph. So the coordinates of E is something I can put in immediately. So this is 0 and minus 7 over 2. What else can I find? I've got a line graph. So a line graph has got an x-intercept and a y-intercept. So, if I want the x-intercept, I'm going to set y equal to 0. Now 10. X-intercept. I'm going to set y equal to 0. I'm working with the equation that I've got. So y is equal to half x minus 7 over 2. Notice, ladies and gentlemen, 0 is equal to a half x minus 7 over 2. A constant is negative, I'm taking it to the left-hand side. 7 over 2 is equal to a half x. Right. How do I get rid of the denominator? I can multiply both sides by 2. So 7 is equal to x. In other words, my x-intercept, xy, is equal to 7 and 0. Now the first question is, was, show that the coordinates of C are 7, 0. And there I've just about solved it, and that is C, and that is 14.1. The next question says, calculate the x coordinate of D. Now, for those of us that still remember, I did this with you. I said to you, now I can write it in. This coordinate pair here is 7, 0. Now, we know that this is the axis of symmetry, so it has coordinate pair 3, 0. Now, we can easily find this point by using a formula and by simply knowing the distance between them. You see, the distance on this side is exactly the same as the distance on that side. So, how many units from 3 to 7? 4 units. It's 4 units. Therefore, I must count 4 units this way to get these coordinates. So, let's just see. If I add 4 here, can you see this is 3 and 4? So, the coordinate pair here would be minus 1 and 0. Okay? If I've just added the coordinates. But, there's another way to do it. So, the distance between the points, between axis of symmetry and C is 4 units. Therefore, I need to take 3. If I want to, subtract the 4 and I get minus 1. So that's my minus 1 coordinate for that one. Or, how can I else could I have done it? You know the story. If you want the axis of symmetry, you add the 2 roots and you divide by 2 and you get the axis of symmetry. So what do we got now? We haven't got 1 root, 7 over 2, and we've got the middle. So, let's see. Cross multiply, x1 plus 7 is equal to 2 times 3, so I get 2 times 3, and this will become 1 times that. So I get x1 plus 7 is equal to 6, x1 is equal to 6, minus 7, x1 is equal to minus 1. So there we go, ladies and gentlemen. Adding the roots, dividing by 2 gives me the axis of symmetry. I've substituted. My axis of symmetry was 3. One of my roots is 7. Right? I've cross multiplied and I've managed to find the missing root. So my missing root at B is now minus 1 and 0. So it's not complex if you know how to do it. The next question is, determine the equation of f in the form y is equal to a x minus p all squared plus q. Now, let's see. What do we have now again? We've got 2 roots. So, we've got 2 roots. So, we've got, what do we have now again? Which roots do we have? We've got x equal to minus 1. We've got x equal to 7. And we've got the y-intercept at, do we have the y-intercept? Yes? We have the y-intercept at minus 7 over 2. In other words, ladies and gentlemen, I can do the following. I can say y is equal to, okay, let's just write it in the right place, and this becomes x plus 1 is equal to 0. This becomes x minus 7 is equal to 0. This becomes, okay, y minus 7, this becomes a coordinate pair 0 minus 7 over 2. We can go and use the root formula. But we do know something else. We know the axis of symmetry. Right, so the axis of symmetry, they're giving me x equal to What is it? X equal to 3. Now, they want the axis of symmetry formula. So y is equal to a. X minus p all squared plus q. Now let's see how we can work with it. We've got a number of sets of coordinates. This can become x minus 1, 0. This one is 7, 0. Okay, so we don't need to use this. We can use the axis of symmetry. We've got this point. We've got, which other point do we have? We've got this one. And we've got another one. We've got 3 points. Okay, so now we can put in our axis of symmetry. How does the axis of symmetry work? X minus 3 is equal to 0. So now I substitute a. X minus 3 all squared plus q. Next step. I need to find q and I need to find a. So let's put in one of my roots. So let's substitute with one of the roots. I'm going to take minus 1, 0 and substitute it. Well, y is 0. X is minus 1. Minus 3 all squared plus q. Don't worry about the two equations. I'm going to take another set of coordinates, namely 7, 0. Let's put it just down here. And I'm also going to substitute it into that equation. So, 0. Can we just simplify this equation first? 0 is equal to a multiplied by, this is minus 4, all squared will give me 16. So this gives me 4 squared plus q. This is going to give me 16a plus q. If I substitute 7 into here, then I'm going to get 0 is equal to a. 7 minus 3 all squared plus q. So 0 is going to be equal to a times 7 minus 3 all squared plus q is going to give exactly the same thing. I don't want the same thing. So he's not working so nicely. Let's use another point. It's going to give me exactly the same point. I can't use that one. The roots are giving me the same. So let's see if I can use minus 7 over 2. Let's use minus 7 over 2. Unfortunately, he's giving me the same point, so 0 and minus 7 over 2. Let's see. If I put in, this is 16, 0 is equal to 16a plus q. If I put in minus 7 over 2 is equal to a multiplied by 0 minus 3 all squared plus q. Minus 7 over 2 is equal to a. This gives me 9 plus q. Minus 7 over 2 is equal to 9a plus q. Now ladies and gentlemen, what is the point behind this? Can you see that I've got two equations, one equation here, and I've got another equation in A and Q. So I've got two equations, and now I can subtract them. Now let me give you a minute to catch up if you're a bit stuck. What I've done, ladies and gentlemen, I'm looking at this equation, and I'm going through all the things that you can possibly ask in a question. Namely, if you're given a graph, they didn't ask you to draw it, but you've got to find different things. What I want you to notice is what we do with the graph. We first put in the things that it has, and then we start the graph. We work from the known to the unknown. You will notice we started with a line graph, and the line graph, we started with the x-intercept. Why did I start with the x-intercept? Because I had the y-intercept, but I missed the x-intercept. It just so happens that the first question asks for the x-intercept. The next question asks for the x-coordinate of your, the x-coordinate b, which is a point on your parabola. So I needed to find it, and I already had one x-coordinate and the axis of symmetry. I could do it by using the distances, but I could also do it the way I showed you using the axis of symmetry. adding the roots, dividing by 2 finds the axis of symmetry. So I could do that. Okay? The one that I'm doing right now is I'm finding the equation of f in the form that they're given to me. So, I'm using what I have instead of going to work out the equation of the line. Many of us would go and work out the equation of the line first, in standard form, and then go and rewrite it and complete the square. But there is another way. You have the axis of symmetry, so I'm substituting points that I have already got. You'll notice I'm trying to put both roots in. They gave me the same thing. So I have another point. And that point was my y-intercept. So I've got one x-intercept, one y-intercept. Now I've got 2 equations with 2 unknowns in them. And I can solve. So what am I going to do with these 2 equations? Well, ladies and gentlemen, I'm simply going to subtract it. So I've got 2 equations with 2 unknowns. In other words, I've got 0 is equal to 16a plus q. And I've got minus 7 over 2 is equal to 9a plus q. So there's equation 1, there's equation 2. All that I'm going to say is equation 1 minus 2. This one minus that one. So 0 minus that one, this is what it means. Equation 1, subtract equation 2. Okay, minus equation 2. So it's rather good minus so that you realize I'm subtracting. Okay, here's what I mean. So 0 minus 7 over 2 gives me 7 over 2. Okay? 16 minus 9 gives me 7. 7a. Q minus q gives me 0, so it cancels. So I've got 7a is equal to this. So let's cross multiply. So whole numbers over 1. So 7 times 2. So 7 times 1 is equal to 2 times 7. So what do I have? I've got 7 is equal to 14a. Divide by 14, and what do I end up with? 7 over 14 is equal to a. So a half is equal to a. I've got a. A is a half. Let's substitute it into number. Let's substitute this in number, the first one. So now substitute a equal to a half into equation number 1. So 0 is equal to 16 times by a half plus q. So 0 is equal to 8 plus q, and q is simply going to be equal to negative 8. So let's see. What is my equation then going to be? Y is equal to a is a half, x minus 3, all squared plus, no, not plus 8, minus 8. Minus 8. There we go, ladies and gentlemen. I have now just sorted out my equation of the graph. So notice where I started. I used my asymptote. Not asymptote, my axis of symmetry first. Then what did I do? I tried to substitute into my standard form. What did I do? I substituted my x-intercept, that's my y-intercept. I got 2 equations. What did I do to 2 equations? Well, I subtracted them, right? When I subtracted, I got one variable, I found a. I then find another variable by back substituting, in other words, and there I got my equation of my graph. ladies and gentlemen, this is quite a mouthful that I've said. All I'm doing is, I'm looking at the equation, I'm trying to find the equations of the graphs by the material that I'm given. The way you do well in graph work is by practicing the sum. They only look difficult, but they're things that you do know. Okay. Shall I continue or shall I wait first? Shall I continue or wait first? I don't mind. Guys, we've worked through the lunch break. You better have your breakfast. Sorry. Okay, have lunchtime.
come aside, okay? Let's just try and get through after this. You understand this? You understand this?
Yes.
You understand
The
this?
restraint law.
Hmm?
The restraint law.
That's what I'm talking. All of them,
Yeah.
let's look for them and see.
I'm telling you, they're going on. Thank you for the restraint law. Thank you so much.
Thank you. Thank you so much. Just keep getting your favor. So you guys connected me easily without any
Can we start? We don't have much time. I'm going to start again. Alright, let's complete this particular problem. Okay, I'm going to start. Okay, let's look at this particular problem as if we haven't done it yet. I just want to add a question here. GH. I want us to find that distance because that's also a common problem. Okay, it says in this thing, we have a sketch, we are given a graph. G of x is equal to x minus 2 minus 7 over 2. First thing I told you, rewrite this into a form that you do know, which is the form of a straight line, namely, where we have a half x minus 7 over 2. Now you know this it can be compared to y is equal to mx plus c. I've checked that it's not a parabola because the raised power of x here is 1. Okay, now we have the y-intercept already because we know that it is the last term, it is c in my equation, and I fill that in. I'm also given an axis of symmetry. So, because I have a line graph, I can go and find the x-intercept. So that's what I'm going to do immediately. And my x-intercept I find simply by set y equal to 0, and I find it. So, 0 is equal to half x minus 7 over 2. Since that value is negative, I'm going to transpose it, or take it to the other side, and I solve. I can multiply both sides by 2. So, 7 is equal to x. So, this x-intercept for my line is right there where C is. So, the value of C is 7 and 2. 7 and 0. X-intercept has always got a 0 for y. They then ask us to calculate the coordinates of B. Now, there are two ways of calculating the coordinates of B. The one way, you can simply look at the distance between the 2 points. Now, if I consider it carefully, then I know that to move from 3 to 7 is 4 units. So I've got to move 4 units to the left, okay? 4 units to the left and 1 more unit. So that gives me, I've got to move 4 units. So if I move 4 units, there's 3 and another 1 here. So that makes the point minus 1 and 0. Because there's 3, another 1, minus 4. So this will give me the 4 units. So in other words, I can do it by adding the units, by comparing the units, okay? So that's the one way I can do it, 14.2, comparing the units. Comparing units, it is, in other words, 4 units from the axis of symmetry to C, therefore 4 units from axis of symmetry to B. Therefore, B is minus 1 and 0. Then the other way which I showed you is to add your roots, divide by 2, and you can actually find your axis of symmetry. Add your roots and divide by 2. So x1 plus x2 divided by 2 will give us the axis of symmetry. So we can do it that way. So what were our roots? We got x1 we didn't know, but x2 was 7 divided by 2, which will give me my axis of symmetry. We cross multiply. So x1 plus 7 multiplied by 1. First root is equal to 2 multiplied by 3. So x1 plus 7 was equal to 6, and x1 simply was 6 minus 7, and as you can notice, we got the right answer. Okay, next one. Determine the equation of f in the form y is equal to a x minus p all squared plus q. So at 14.3, we asked to find the equation of the parabola, and we need to do something about it. Now the most important thing that we have, ladies and gentlemen, we are given the axis of symmetry, namely x is equal to 3, positive 3. So how do we put this into the equation? We change this. We transpose the 3, so x minus 3 is equal to 0. And I substitute it directly into my equation. So y is equal to a x minus 3 all squared plus q. At the moment, I'm still sitting with two unknowns. To solve the two unknowns, we're going to use two pairs of coordinates that we have. We have an x-intercept there, we have an x-intercept here, and we have a y-intercept there. So we've got three sets of coordinates that we can probably use. Right, so let's use our first set of coordinates. Let's use 7, 0. Let's use that one. If I use 7, 0, y is 7, x is 7, y is 0, a, 7 minus 3 all squared plus q. So 0 is going to be equal to a, 7 minus 3 is 4, all squared plus q. And then we'll get that 0 is equal to 16a plus q. Now if you remember from earlier, when I substitute the other point in, the other value in it, if I substitute minus 1, 0 into it, I'm going to get the same value. So let's do that quickly. So you can see, x1 plus x2 divided by 2, going to be the axis of symmetry. Okay, let's just write it here because it's going to give me exactly the same thing. So if I substitute minus 1 and 0 into it, I'm going to get 0 is equal to a minus 1 minus 3 all squared plus q. So 0 is going to give me a minus 4 all squared plus q, which is 16 plus q, and I'm going to get 16a plus q again. So that point won't work. So I'm going to try the other pair of coordinates, which happens to be 0 and minus 7 over 2. So I'm going to substitute this into my equation. This one here. So y is minus 7 over 2, and y is equal to minus 7 over 2 is equal to a, x is 0, 0 minus 3 all squared plus q. So minus 7 over 2 is equal to a multiplied by negative 3 all squared plus q. Very simply put, minus 7 over 2 is equal to 9a plus q. What I now have, ladies and gentlemen, is I have 1 and 2 equations. We'll call the first one 1, we'll call the second one 2. 2 equations, 2 unknowns, and I can now subtract them. So what I'm going to say is equation 2 minus equation 1. The symbol with the number with the circle around means equation. So it's equation 2 minus. In fact, I mustn't have the word equation there. Just the equation. So it's equation, this stands for equation 2 minus equation 1. So now what do we have? It's 0 minus 7 over 2. So let's write everything there so that you can see. Minus 7 over 2 is equal to 16a minus 9a plus q minus q. There you can see. So what do I remain here with? I'm sorry, this must become a plus because I'm subtracting. So I get 7 over 2 is equal to, I subtract these two, I'll get 7a. The q's are cancelling. It's a whole number over 1, so I'm going to multiply both sides by 2. 7 is going to be equal to 14a. I divide by 14 on both sides. So 7 over 14 is equal to a, which is a half. So now what I have is, I now have a. So y is equal to a half, x minus 3 all squared plus q. Now I just have one unknown. So how do I find that q? definitely will find Q, or I back substitute to find it. In other words, I'm going to take this A, this half, and I can substitute it into my easy equation. So let's put it into the first one. So 0 is equal to 16 times by a half plus Q. And lo and behold, 0 is equal to 8 plus Q, and Q is equal to negative 8. So it's a lot of tedious work, grade 11s. As you can see, it's a lot of planning, keeping your mind together. But there we go, and I'm back to my equation. Namely, I've got the equation. Number 14.4. They asked me, write down the equation of the graph of H, the reflection of F in the x-axis. Reflection of F in the x-axis means I must reflect around the x-axis. Now, if I reflect around the x-axis, ladies and gentlemen, then it means that the smiling graph must become a frowning graph. So, they want me to go, this is my graph at the moment. So, this is fx. Right. They want me to go from this graph, they want me now to do this. Flip it. In other words, this graph has got a positive A. They want me now to get this graph which has got a negative A. So how do I do that? I'm going to, can you see? I'm going to change Y. So what I do is, I do the following. I rewrote the sum, I re-explained it, I put it back on so that you can see that there is an order. So what does it mean if I must reflect around the x-axis? I always say to the learners, where are we going? If you must reflect around the x-axis, then you're going from the one to the other graph. So you're going from your graph as it is to the other. Now what is going to change? The y value is going to change. So, if fx, right, was equal to, what did we say? A half. X minus 3 all squared minus 8. X minus 3. Okay, here's my equation. So let's form a new equation. So hx is equal to minus fx. In other words, this whole graph must reflect or must change, and it's going to change from being a positive to a negative graph. So in other words, I'm going to take my graph and I'm going to put a minus sign. That's all. This is a reflection in the x-axis. So my x that I had becomes negative. So what I do is, hx now becomes negative sign multiplied by a half, x minus 3 all squared minus 8. What then happens? This becomes negative a half, x minus 3 all squared, and this becomes positive 8. In other words, my turning point is going to remain where it is. This is going to be here, and this is still going to be 3, but my y value will now become positive 8. That is the only thing that's going to be revealed. Okay? X intercept stay the same, just my y value. Then there is determine the value of tx. If tx is equal to 1 minus fx, so tx is equal to 1 minus fx. How do I do this? So tx is going to be equal to 1. You already have minus fx. So you can simply go and put it there, or minus a half. X minus 3 all squared minus 8. Can you see what I'm doing here? Plus 8. Right? I'm just going to remove my brackets. So it's 1 minus a half. X minus 3 all squared minus 8. And you can see what happens. I'm getting a different graph, and it gives me the following. That is tx. Here we go, ladies and gentlemen. I've done what they've asked me. They said 1 minus fx. So 1 minus whatever the graph of fx was, there I did it, and I used my solution. In 14.6, solve for x. If f of x squared minus 2 is equal to 0. So, every place that I see an x, I must substitute x squared minus 2. So f of x is equal to a half x minus 3 all squared minus 8. So this means x squared minus 2 means replace x with x squared minus 2 minus 3 all squared minus 8. And you see that my x has now changed. So now I simplify. X squared minus 5 all squared. Okay? Minus 8. And this they say must be equal to 0. So, I'm good. Let's see what we get here. So 8 must be equal to a half x squared minus 5 all squared. There's a 2 on the side, so I'm going to multiply by 2 on both sides, and I get 16 is equal to x squared minus 5 all squared. How can I get rid of the square? I'll take the square root of both sides. Right? So 4 is equal to x squared minus 5. It's actually plus minus. Okay. So if x squared minus 5 is equal to plus 4, or x squared, no, just say x squared. X squared minus 5 is equal to minus 4. So x squared is equal to 4 plus 5, or x squared is equal to minus 4 plus 5. X squared is equal to 1. So x is equal to plus minus 1. Here, x squared is equal to 9. X is equal to plus minus 3. 3 squared is 9. 9 minus 5 is 4. 4 squared is 16, and half of 16 is 8. Doesn't matter if it's positive or negative because of the square. If I put 1 in there, 1 squared is 1. 1 minus 4, 5 is 4. 4 squared is 16. 16, half of 16 is 8. So there I go and there I've solved. So ladies and gentlemen, I've just done what they asked me to do. Straightforward substitution. Straightforward. Notice that all I've done is I've replaced x with x squared minus 2. I've simplified. That's all I've done. They asked me to set it equal to 0. I've done that. I've solved. It's just numbers that I've got. And that's where I've done. I've even checked it. And because of the square there, it doesn't matter which one they choose, it will always work out. So ladies and gentlemen, that is question number 1.14. Now there are a number of questions. I'd love it if you can work it out for me, and we can eventually even talk about them so that I know how you are faring with these questions. That's one of them. Okay? So that finishes, or that is where we look at those questions. Are there any questions so far? Shall we do another one on that page? Do you think it's necessary? Can you see the exam question? There's an exam paper question on functions. Perhaps we should look at that one. Question number 5. Sorry about that. Okay, on the exam paper questions on functions. Alright, let's look at question 6, and all I'm going to do is I'm going to talk you through it. 6.1 says, given the function fx is equal to 3 over x minus 2 minus 3. So I'm not going to work everything out for you. I'm just going to go through some of the questions with you to see and make sure that you understand what we're asking for. Okay, 5.6, sorry. The question is, given the function, if x is equal to 3 over x minus 2 minus 3. Now, write down the equation of the asymptotes of fx. I have a look at my equation. I must recognize which mother I'm busy with. My x is in my denominator, so I know that I have a hyperbola. So that's the first thing I need to know. What type of graph it is. I need to know that type of graph. I must isolate it. In other words, I must know that this is not a line graph, because in a line graph, the highest power x is 1, and I have nothing in my denominator. It's not a regular, because there's no square. It's not an exponential graph, because then the x must be in the air, kind of. So it's an hyperbola. Second thing that I must realize is where everything fits. Namely, in the denominator, what do I have? I have my vertical asymptote. That's my vertical asymptote. Then, anything that is added on. Anything that is added on. This is my horizontal asymptote. Okay? Last but not least, I must take note of A. A is in this case larger than 0. So I think of it very, very briefly. My graph must kind of like be in the first and the third quadrant. So I can't make unnecessary mistakes. So I must recognize the hyperbola. I recognize where to see the vertical asymptote. My add-on is the horizontal, and A is positive, so I'm expecting this kind of shape. So they ask you to write down the equations of the asymptote, determine the intercept of the graph with axes. Now, that one I didn't practice with you, so let's just look at the x-intercepts. The x-intercepts for this kind of graph, set y equal to 0. So it works exactly the same like the others. So 0 is equal to 3 over x minus 2 minus 3. This part is negative, so I take it to the other, transpose it to the other side. So I get 3 over 1 is equal to 3 over x minus 2. I'm going to cross multiply. For those of you that are still stuck, the denominator on the right multiplies with the numerator on the left. The denominator on the left multiplies with the numerator on the right. So I get 3x minus 6 is equal to 3. So 3x is going to be equal to 3 plus 6. 3x is going to be equal to 9. I'm going to divide by 3 on both sides, and x is going to be equal to 3. So I don't use a table, I just find my x-intercept. The last one, find the y-intercept. How do I find my y-intercept? I'm going to set x equal to 0. So in my equation, y is going to be equal to 3 over 0 minus 2 minus 3. Again, anything added to 0 is the adding or the anything minus 3. So y in this case is just going to be negative 4.5. Okay, so there I now have my x-intercept, my y-intercept, and now I can draw my sketch. So this is what happens, ladies and gentlemen, for us when we draw our sketch. All I'm going to do is put my asymptotes in. 1, 2, 3. 1, 2. And this is the negative side. This is the positive side. Minus 1, up 1, sorry, 2, 3. And so, very briefly, not for the table, I'm drawing my graph. So what do I play now? First, my vertical asymptote. X is equal to 2. So there it goes, it's a dotted line. X is equal to 2. My horizontal one, x is equal to, y is equal to minus 3. Right, if you just draw this line a little bit longer, I'm expecting it to line this quadrant and the first quadrant. Next step, my x-intercept, where is it? Minus 4, my y-intercept is at minus 4.5. 4.5, so minus 4, minus 5, minus 4.5. sorry, minus 4.5. There it is. That's my y-intercept. My x-intercept is at 3. Wow, that's not funny. 3. 3 and 0. Now maybe you're not so sure where now. Which way is it going to go? Is it not even looking like anything that you do know? Well, you can put another point in it. We can go and put minus 2 in it. So if I put minus 2 or even minus 1, let's see if I put minus 1 in it. So if x is equal to minus 1, then I'm going to get 3 minus 1 minus 2 minus 3, and I'm going to end up here with 3 over minus 3 is minus 1, I'm going to end up here with minus 4. So if x is minus 1, y is minus 4. Okay, so now I know that this graph is definitely in this quadrant, because my point that I'm getting is when x is minus 1, y is minus 4. This one over here, if I go and put 5 in there, if I say that x is equal to, not 5, let's put in another value, x is equal to, yes, it's right, if x is equal to 5, then I'll get 3 over 5 minus 2 minus 3. 5 minus 2 is 3, so 3 over 3 minus 3. So I'll get 1 minus 3, which is 1 minus 3, which is minus 2. So, at 5, and minus 2 comes across here. So this is 5 and minus 2, and lo and behold, ladies and gentlemen, my graph is going to go through my point somehow. I can't draw it intended really. I have to draw it from the side. Okay, it's going to go through that point there. It's going to move closer and closer and closer and closer until it will move to my asymptote there. And there you go, ladies and gentlemen, there is my graph with the minimal things that I need. X-intercept, Y-intercept. If you're still not sure about your points, find another point that you can. Notice I didn't go and look for a point on the one side. I look for points that will fit the asymptotes yes, so that I know where to find it. Is it first and third? Yes, it is first and third. So what my prediction was is correct. If they had asked me to find the equation of the asymptote, ladies and gentlemen, so that you get familiar with it, the coordinate pair here is 2 and 3 minus 3. If they had asked me to find the equation of the asymptote, I know it's going in the negative direction, so m is equal to minus 1. Our pair of coordinates is 2 minus 3. If I use my equation of my line, this is what will happen. X plus c, and now I substitute it. Minus 1 multiplied by 2 plus c. So minus 3 plus 2 is equal to c. So my axis of symmetry for this graph is going to be the following. The axis of symmetry for this graph is y equal to negative x minus 1. That is my axis of symmetry for this graph. In other words, this graph, if I do it 100% correct, no, it's not there. It's actually going to go through positive 1 there. Isn't that wonderful for you to know that it's actually going to go through but my positive 1 minus 1. Why am I thinking so out of box? It's actually going to go through minus 1 and leave there minus 1. And x is going to go through minus 1 as well. So it's going to go through these 2 points. Isn't that wonderful? This is my axis of symmetry. Okay. Is my axis of symmetry for my graph. So this, in case you were wondering about the axis of symmetry, am I talking nonsense? This is my axis of symmetry. A fold line, how to find it, there it is. So, I've drawn it. So, ladies and gentlemen, this is a cold 8 marks for you if you really know how to do it. It's very interesting, and you can really score your marks here if you know how to do it. Write down the equations of the axis of symmetry. They asked us. Write down the range of fx plus 2. The range of fx plus 2. So what are they asking me to do? Fx plus 2. So the range of fx plus 2 means I must take my original graph. So this is 3 over x minus 2 minus 3 plus 2. So this gives me my original graph minus 1. Okay. What's my range going to be? My range is going to be, let's look at the range of this graph. What is range referred to? The y-axis, where you come from bottom to the top. So will this graph pick up y values? Of course it will pick up y values. Of course. It's going to pick up y values. And then it's going to hit the snag. And the snag is going to be because of y equal to minus 3. Where is it? It is the snag here. That add-on piece. So now I know, I don't even have to work further. I know what it will be. So it will be y an element of the reals except the asymptote y equal to minus 1. That is what the range is. So ladies and gentlemen, that then finishes question number 6 for you. I did it so that you can see we don't use a table, you just have your x-intercept, your y-intercepts. Remember the check right at the beginning. What have I got? What do I need? X-intercepts, y-intercepts. If I plot it, this case my x-intercept and my y-intercept are far from each other, they're in different quadrants. I had to use another point to make sure my shape is correct. And there we go. I even found your axis of symmetry equation, which they do ask you for. So I've drawn the graph equation of the axis of symmetry. And if I wanted to, I could also find the positive one. I'm not so worried about the positive one. I'm more concerned about this one, so that you understand what is happening. Okay? So, yes. Hopefully your sir will do 6.2 with you and 5.1 with you. Now, this is not the end of functions, but functions play such an important role. You will have noticed we've covered most of the aspects of functions, and I do hope that you learned something out of it, that you've gathered quite a bit of information. I do know it's a lot, but I trust that as you work through it, as you go through the problems, you will indeed see and pick up things that I pointed out to you. So this is the end of my role. Your teacher will obviously do some practice with you, make sure that you understand everything, ask the questions that you don't know, otherwise you need to post it on the chat and I will get back to you. Tomorrow we're going to look at some traits first, and then we're going to look at the geometry, which is a short. Okay? So, if there is nothing further for today, I wish you well for the evening. Have a brilliant afternoon and enjoy the rest of the day. Thank you.